From Vandenberg Air Force Base in Central California, you're watching live launch coverage of NASA's ICESat-2 mission to unlock the mysteries of our home planet's frozen and icy areas. Good morning. I'm Stephanie Martin, and thank you for waking up early with us. We have team coverage of today's launch from NASA's Joshua Santora and Mick Weltman in the Mission Director Center with the launch teams, and live in-depth interviews with NASA's Chris Gersh, Blair Allen, and Franklin Fitzgerald, covering everything you need to know about the final Delta II launch and ICESat-2's mission. But first, today's launch is targeted to lift off at 5:46 this morning Pacific Time from Space Launch Complex 2 at Vandenberg Air Force Base. The launch window is now about 60 minutes long. ICESat-2 is short for Ice, Cloud, and Land Elevation Satellite, and will measure global ice elevation, sea ice, land topography, and vegetation. ICESat-2 is a follow-on to NASA's original ICESat mission, which launched in 2003 and was operated through 2009. Today's launch is the final launch of a United Launch Alliance Delta II rocket and the 54th NASA launch on a Delta II, which is often referred to as the industry workhorse. Coming up, we'll share how ICESat-2 will advance our understanding of how our Earth is evolving. But first, we're now about 34 minutes away from launch. Let's check in with NASA's Joshua Santora and Mick Weltman in the Mission Director Center.
Hey, a very good and early morning to you, Stephanie. I am Joshua Santora.
I am Mick Weltman, and glad to be here, Joshua.
Yeah, it's been a really exciting morning already. Mick, lots going on, lots to come. What's happened so far this evening, or this morning?
Yeah, this morning, the teams got on console very early this morning, started with their tower rollback, the mobile service tower rollback, to getting the Delta rocket exposed to the environments. The team continued their work with the SRM final connects, or solid rocket motor final connects. Then they began removing and configuring platforms on the launch mount to make sure the vehicle was ready to go for this morning. After that, they did some guidance checks on the RIFCA, the inertial navigation system, which tells the rocket where to go once we lift off. The team is continuing to work methodically through their procedures and look through everything that needs to be done. We did start tanking RP1 a little earlier this morning and just completed cryo load of liquid oxygen into the first stage tank. So as of right now, the team has got the vehicle configured and finishing up their final range checks and getting things ready for a 546 T0.
Yeah, and you'll notice on your screen today, at multiple points, you'll have our timers up there. We have two timers, the L time and the T time. The L time represents the amount of seconds and minutes until 5:46, until our launch time. The T time is accurate, but it's actually counting. It's a part of our countdown procedure. And so you'll notice they're not synced up. And the reason for that is that we have some planned built-in holds that allow us to get some work done and kind of meet some milestones before proceeding. And so we'll talk a little bit more about what happens during those holds here in a little bit. But to give you kind of a highlight of some of the things coming up on the show today, we have the second to last of our built-in holds here in just a couple minutes. We'll be starting into that hold. It'll be 5 minutes long. And then we have another one at 10 minutes long later in the show. And so, Mick, it's a very active scene this morning. There's a lot going on. We also have a weather briefing coming up here shortly.
Absolutely.
All week, the weather has looked fantastic. We're hearing there's a little bit of question about high altitude winds, but we're seeing good trending data, so we'll know more about that shortly.
Yeah, the team has been working with the range, United States Air Force, with our weather balloons and trying to determine what the winds look like at the upper levels so the rocket can fly through those and make sure we have everything configured right. And as of right now, things are trending in the right direction for the Delta II launch vehicle, and we'll hopefully hear a little bit more about how the weather is from our launch weather officer. But as you stated, this week has been just amazing weather out here, and as you can see on the screen, beautiful shot of the Delta II out at Slick 2 today, Space Launch Complex 2, and it's just gorgeous to see that rocket and no fog right now. So that's amazing for us to have that out here in Vandenberg Air Force Station.
Yeah, the weather can be a little troublesome here, but other things that are coming up on our countdown, we're going to take a look at the Delta, the history. It's the 155th flight of the Delta II, so a very long history spanning almost 30 years, and this is definitely a nice way to kind of end a legacy and send off the Delta II in a very fitting fashion.
Absolutely. NASA's been using the Delta II for 30 years, launching many notable missions, including our Mars rovers, MER A and B, which were later named Spirit and Opportunity, our Phoenix Mars lander, and, Delta II also launched a lot of GPS missions over the years, which has touched everybody's life over in the world since that started. So we have to thank the United States Air Force for getting that started back in the 80s.
Absolutely. So two things coming up right now. We're going to step into that planned built-in hold here in about 10 seconds, and then we're going to hear from our weather officer at the U.S. Air Force 30th Space Wing, First Lieutenant Daniel Smith, and we should be at 3, 2,
T-minus
1,
15 minutes
T-minus
in holding.
15 minutes in holding.
5-minute built-in hold.
So we'll be here for 5 minutes, again doing some checkouts, and we're going to check in with the weather officer when he comes up here. I think it's coming in now.
LD. RC. NLM. NLM. OD. Slick. I will provide current and predicted T0 status for safety and launch agency constraints with the probability of violation.
This is the LWO. This briefing will be displayed on CCTV's channels 9 and 10, beginning with channel 9. Current satellite loop indicates upper clouds over north-central California with low clouds over Vandenberg. Current radar loop indicates no returns over station. Winds at the 102-foot level on Tower 102 show winds out of the northwest at 340 degrees at 14.6 knots. Turning to channel 10. Weather is currently green. There are no watches, warnings, or advisories in effect for Vandenberg Air Force Base. Proton flux is at background levels. In our T0 forecast, we are forecasting low clouds with bases at 1,000 feet. Visibility is now unrestricted with no weather. Temperatures will be in the low to mid-50s. And the overall probability of violation for all range safety LCC and user constraints is 0%. For scrub day, the low clouds will be at 200 feet. Fog, there will be low visibility 1 to 1/2 statute miles. Due to fog, temperatures will be in the low to mid-50s with winds out of the north at 8 to 12 knots. The overall probability of violation for all range safety LCCs and user constraints is 0%. This concludes my briefing.
OVO indicates clear to proceed. All station report questions are acknowledged. OVO.
Hello.
RC. LD. NLM. OD. Slick. Weather conference net clear.
All right, so as you heard, a great report there. 0% chance of violating the weather constraints at liftoff. Mick here got really excited when he heard there was unrestricted visibility.
Yeah, we've been talking all week about low-level fog and possibly not see anything, but unrestricted visibility is amazing here at Vandenberg, and I'm so excited for the folks that will be watching this tonight.
Yeah, that is great. There's lots of people around here that are gathered. Big shout out to those folks. Another interesting point that was mentioned there is the photons at background levels. The weather officers here actually monitor space weather as well. That plays a factor in being able to launch successfully, so no issues there either.
Absolutely. It's a requirement we need to look at for all the components on the launch vehicle, especially our avionics and guidance systems, right? Make sure that the rocket can perform how it needs to be and put this spacecraft where it needs to go.
Yeah, so there, again, we have our center stage, the Delta II. Mick, tell us about this specific Delta II that's going to be hoisting ICESat-2 into space.
Yeah, the final Delta II here is an amazing vehicle. Delta II launch vehicle that we're launching this morning for the ICESat-2 mission is a 7420 version, which is a 7000 series vehicle which uses 4 graphite epoxy solid rocket motors, an AJ-10 stage engine, and no third stage. That's what the 420 stands for. The -10C is the composite fairing for today. The core of the Delta II rocket, or first stage, utilizes RP-1 and liquid oxygen to power the Aerojet Rocketdyne RS-27A engine. In conjunction with the RS-27A, we have 4 graphite epoxy solid rocket motors, or GEMs, that are ground lit, and they provide that extra thrust to give ICESat out of Earth's atmosphere. The Delta II rocket's second stage uses Aerozine 50 and nitrogen tetroxide to fuel the Aerojet Rocketdyne AJ-10 engine. The second stage provides the power needed to put ICESat-2 into its initial orbit. During ascent, of course, the spacecraft needs to be protected, and we do that with a 10-foot composite fairing. All of these features of the Delta II vehicle play an important role in getting ICESat mission on its way to study ice, cloud, and land elevation.
Yeah, thanks, Mick. So we just actually heard our our NASA launch manager, Tim Dunn, chime in and made a great declaration. We got off to a little bit of a late start this morning, but we've caught up. So we are targeting that 5:46 a.m. Pacific time liftoff, and we actually are going to be coming out of this planned built-in 5-minute hold in just a few seconds, which, again, that weather briefing was a big part of that.
Absolutely.
They've checked the boxes. Things look good. So we'll get the clock moving again. And
The team has done very well to get us here.
yeah, they have. And we'll get into the team and kind of who's involved in that in just a second. But in 4, 3, 2, 1, that's 15 minutes in counting.
Top off second stage helium.
All right, Stephanie, great reports from out here. The launch teams continue to progress with things as expected and hoped. The weather looks phenomenal. So we're going to send it back to you to learn more about the science on board that Delta II will be lifting into space this morning.
Thank you both. We're now just a little under 24 minutes away from today's launch. Some of you may be wondering why we are studying the cryosphere, or the frozen water on Earth. Well, ICESat-2 will capture frequent and precise measurements of the Earth's ice using lasers that pulse more than 10,000 times per second. The data collected will allow scientists to analyze where water is flowing, melting, and growing, and to investigate the global impacts of these changes. ICESat-2 will also survey the topography in forests, lakes, urban areas, cloud cover, and so much more. Once in orbit, ICESat-2 will be located about 310 miles above the surface of the Earth and will repeat that same orbital path every 91 days. This means that it will capture a grid of the entire Earth every 3 months, capturing seasonal changes. Earth is a complex, dynamic system that we do not yet fully understand. The purpose of NASA's Earth Science Program is to study scientific understandings of our Earth system and to improve predictions capabilities for climate, weather, and other natural hazards. To learn more about how ICESat-2 fits in with this larger portfolio, let's check in with NASA's Chris Gersh, who is with Associate Administrator for the Science Mission Directorate, Dr. Thomas Zurbuchen.
Thanks, Stephanie. You're right. The Earth is a complex, dynamic system that we fully don't understand yet. And Thomas, how does ICESat-2 fit within the NASA Earth Science Program portfolio?
Well, it's a major anchor of that portfolio as we go forward. We have 19 missions already in flight, 20 under development that will launch in the next 5 years or so. So, we'll put that up there, and it will become one of the key elements looking at, of course, the cryosphere, the frozen part of our Earth, especially our frozen water, right? That is such an important part for all of us.
It's been a big year for science. Just a little over a year ago, we're still mesmerized by the pictures from the total solar eclipse. And last month we had Parker Solar Probe launch, a great heliophysics mission heading towards the sun, and now ICESat-2. Just kind of talk about, when we talk about weather and climate change, doesn't start with the Earth. It really starts with the sun. And how does that system interact?
You're right. Whenever we think of the Earth, of course, we think of it in the context of the solar system, entire universe, and all the missions that we're launching, whether it's Parker, whether it's missions to look at other planets elsewhere in the galaxy, all of which we've launched this year alone, in this anniversary year. It's a really important part to look at it that way. So it's the sun with its radiation, but also with its space weather that are affecting our lives in our technological society. Yes.
Now, Thomas, I know you have to go on console, but I want to ask you one final question. Last Delta II launch for NASA. Kind of share your emotions about the launch vehicle and how it's been a workhorse for the agency.
So what I did yesterday is I looked up every single science mission that ever launched on a Delta II, and I realized that all but 2 things that I ever did were launched with a Delta II. So were 50 plus other science missions. Right. It has affected all of the science portfolio. It has unlocked the heavens to our eyes. So the Delta II is just such a marquee tool that we'll never forget.
Well, Thomas, thank you so much for being on the show today, and good luck with the launch a little bit later.
Thank you so much, Chris.
Stephanie, back to you.
Thank you so much. For those of you who are just joining us, we're about 21 minutes away from today's launch. You're looking at a live shot of NASA's ICESat-2 poised. NASA's original ICESat mission was launched into orbit in 2003. The spacecraft was able to capture data of Earth using a geoscience laser altimeter system known as GLASS. This animation shows the cloud data that was collected from about 15 orbital passes of the Earth in October of 2003. The single-beam glass laser fired 40 pulses a second, taking measurements every 170 meters along the satellite's track on Earth's surface. While that provided great data, NASA's ICESat-2 will take advantage of new technologies providing greater data. About the time NASA's original ICESat mission ended, we began Operation Icebridge, the largest airborne survey of Earth's polar ice ever flown. It utilizes a highly specialized fleet of research aircraft and sophisticated suite of innovative science instruments to characterize annual changes in thickness of sea ice, glaciers, and ice sheets. These flights will provide annual look at the behavior of rapidly changing features of Greenland and Antarctic ice. This airborne research has been critical for ensuring a continuous series of observations of Earth's ice. When paired with the last 15 years of data gathered from the original ICESat and now Operation Icebridge, ICESat-2 data will allow scientists around the world to track historical trends. We're now a little more than 19 minutes away from today's launch. Let's review some quick facts about today's ICESat mission.
NASA is about to launch the most advanced laser instrument of its kind. The Ice, Cloud, and Land Elevation Satellite-2, or ICESat-2, will measure changes in glaciers, ice sheets, and sea ice. So, to prepare for launch, we're counting down 10 quick facts about ICESat-2. 10,000. That's how many times the ICESat-2 laser will fire each second. More pulses mean more height data. The fast-firing laser will allow us to measure the average annual change in the vast ice sheets down to the width of a pencil. 9 years of data from Operation Icebridge will be added to ICESat-2's new data. The airborne mission bridged the gap between the original ICESat and ICESat-2 with flights over the Arctic and Antarctica. 800 picoseconds, less than 1/billionth of a second. That's the precision at which individual laser photons will be timed as they complete their round-trip journey from the satellite to the Earth and back. 7 kilometers per second is how fast ICESat-2 will zoom above the planet. It'll complete an orbit around Earth in 90 minutes. The orbits will converge around the poles, focusing the data in the regions with the most expected change. 6 laser beams split from 1 on board ICESat-2. That's 6 times the beams of the original ICESat. More beams will cover more ground, or ice, and allow scientists to assess the slope of the surface they're measuring. 532 nanometers, the wavelength of the bright green laser. When these laser photons return to the satellite, filters block any light that's not exactly at this wavelength, keeping the amount of data noise down. 4 times a year, every 91 days, ICESat-2 will measure the same ground tracks, allowing scientists to see how glaciers and other frozen features change with the seasons, including over winter. A 3D look at Earth, now with more height. ICESat-2 will measure elevation to see how much glaciers, sea ice, and ice sheets are rising or falling, and give us a more complete picture of our planet. There are 2 types of ice that ICESat-2 is after, land ice and sea ice. Land ice builds up year after year from snowfall, but sea ice forms when the ocean water freezes. It can last for years or just one winter. Only one instrument, but it's a really good one. The Advanced Topographic Laser Altimeter System, or ATLAS, was built by hundreds of people at NASA's Goddard Space Flight Center to exacting requirements so that scientists, very soon, can measure minute changes in our planet's ice.
All Delta missions dating back to the first Delta launch in 1960 have been numbered. Today's final Delta II launch is carrying the number 381, signifying that it is the 381st flight of the Delta family. Additionally, each rocket has had stars on it, recognizing the previous missions flown. Today's vehicle has more than 150 stars, with over 800 signatures from people who have been a part of the Delta II program. Now that you know a little bit more about the history of the Delta II and the team behind these launches, let's hear from NASA Administrator Jim Bridenstine.
While I'm sorry I can't be at Vandenberg today, it is my pleasure to celebrate another exciting NASA Earth Science launch with you. The Ice, Cloud, and Land Elevation Satellite-2, or ICESat-2, will measure the height of a changing Earth, 1 laser pulse at a time, 10,000 laser pulses a second, giving scientists unprecedented detail about the elevation of ice sheets, glaciers, sea ice, and more. One of NASA's most important missions is to utilize space to understand and explore our home planet. NASA's observations of Earth's complex environment are critical to understanding how our planet's natural resources and climate are changing. ICESat-2 will detect as little as a fraction of an inch of change in the surface of land ice covering Greenland and Antarctica from year to year. That's about the width of a pencil. This data will help scientists investigate why and how much our cryosphere is changing in a warming climate. The satellite will also measure height changes across Earth's temperate and tropical regions and take stock of carbon stored in forests worldwide. Many scientists, engineers, and technicians have worked for years to make ICESat-2 a reality. I want to thank the NASA and commercial teams that have made today possible. Their dedication and commitment to advancing American leadership in science and space exploration is greatly appreciated.
We are now about 14 minutes away from today's launch. Let's go back to NASA's Joshua Santora and Mick Waltman to carry us through the remainder of the milestones.
Hey, thank you, Stephanie. Yes, we are now at L-minus 14 minutes and about 20 seconds and counting.
Yes.
T time of 4 minutes and 20 seconds and counting. We're actually about to enter our final built-in planned hold.
That's right.
That will be at T-minus 4 minutes. And so this is a chance, again, to kind of do final polls and make sure that we're ready to proceed with the terminal count. And that should be coming up now in about 5, 4, 3, 2, 1.
T-minus 4
That's
minutes
T-minus
and holding.
4 minutes and holding. Again, the L time continues to count towards that 5:46 liftoff time. So, Mick, what are we doing during a hold specifically? What's going on?
So right now we're in a built-in 10-minute hold. This is the last chance, giving the launch teams on ULA and NASA a chance to look at all their systems, verify all alarms are cleared, verify everything's within specification. They're working nothing that they're worried about to get to a T0. So that's what these holds are for, right? It gives them some extra time to just evaluate and assess anything that they're doing.
Yeah.
We've actually had 3 holds this evening, going back to our 60-minute hold early on.
And Mick, we actually have coming up in just a second, we've got our NASA launch manager, Tim Dunn.
Absolutely.
I hate to cut you off, but I
No,
want to
that's
make sure we
fine.
can listen into his poll. He's going to poll the NASA team to make sure that we're in good shape to move forward. That should be coming up in about 4 seconds. He should kick this off. He's a pretty punctual guy.
Yes.
So I'm not sure what exactly is happening. I don't want to let y'all hang in there. It looks like he's might be leaning in there to kick things off here.
Prop 2, activate and display record on change.
In addition to his poll, a big reason for his poll is that he's actually going to be reporting out in the primary poll, the last poll of the day that happens at L-minus 7 minutes. So he's polling the NASA team so that he can be accountable and report out to the NASA launch conductor, who's United Launch Alliance's Scott Barney.
NASA team, this is NLM. Stand by for the final.
And here we go. Tim Dunn, our NASA launch manager. Poll.
We have a situation with temperatures of helium and nitrogen, bottle temps on second stage. Working that issue right now.
So it sounds like Tim's going to push his poll just a little bit. Sounds like the team may be working some bottle temperature issues. We'll hear a little bit more about that once the team evaluates that. Again, that's exactly what these holds are built in for, is to give the team a chance to look at those things, make sure they come within their requirements. So we'll kind of keep an ear out and see when Tim comes back for that poll.
Yeah, while we're waiting, I want to go ahead and actually throw to a profile video, a launch profile video we've got from United Launch Alliance of the Delta II mission today. So let's go ahead and take a look and see what the whole flight of today's mission is.
3, 2, 1. Main engines start and liftoff. Delta II rocket.
The Delta RS-27A main engine and 4 solid rocket motors ignite to lift the final Delta II rocket away from the pad. Shortly after liftoff, Delta begins a pitch over to attain the proper flight path while minimizing the pressure the vehicle experiences during flight. The Delta II reaches Mach 1, the speed of sound, at 30 seconds. At 1 minute 23 seconds, the 4 ground-lit solid rocket motors are jettisoned. 4 minutes 24 seconds into flight, cutoff of the main engine, or MECO 1, occurs. 8 seconds later, the the Delta II separation system activates, releasing the first stage. The vehicle now weighs a little less than 6% of what it did at liftoff. 6 seconds after first stage separation, the second stage engine ignites. At 5 minutes, the payload fairing is jettisoned. Second stage engine cutoff, or SECO-1, occurs at 10 minutes 53 seconds. The second stage and satellite now enter a coast phase for 36 minutes 41 seconds. At 47 minutes 33 seconds into flight, the second stage engine is reignited for a second burn. Second engine cutoff 2 occurs 7 seconds later. At 52 minutes 40 seconds, the Delta II releases NASA's ICESat-2 on its mission to gather data to track terrain changes, including glaciers, sea ice, forests, and more. Approximately 18 minutes later, the second stage engine ignites for a third burn. The third second engine cutoff occurs at nearly 71 minutes. Deployment of the first CubeSat occurs at nearly 76 minutes, followed 2 minutes later by the second CubeSat. The final 2 CubeSats are deployed 2 minutes later at just over 79 minutes. Together, the CubeSats will conduct space weather research.
All right, so Tim, we're still waiting on NASA launch manager Tim Dunn. He will be coming in at some point in the near future to update us. But for now, we're gonna kind of just we're gonna move into a holding pattern on our end, just to kind of wait and see what they're doing, because obviously we're taking our cues from the launch teams today. Launch teams being a big topic of what's going on.
Yeah, absolutely.
We've said we a lot. I want to talk a little bit about the launch teams that are out here. We've got Northrop Grumman, which is the spacecraft side. They constructed the spacecraft. Also Goddard Space Flight Center from NASA, a big part of that, the science there. We've got the U.S. Air Force. We have NASA Launch Services Program. And then we also have the United Launch Alliance. Obviously, it's their Delta II this morning. So what all are these teams doing to kind of bring this together?
So you're absolutely right, Joshua. We use we a lot when it comes to launching a mission, and it does take a huge team effort. As you outlined, 4 major team players here for this mission, this final Delta II historic, starting with Northrop Grumman, who not only built the spacecraft in their Gilbert facility in Arizona, but they worked with Goddard Space Flight Center, who built the Atlas instrument that we heard about that's on the spacecraft also. Northrop Grumman provided the graphite epoxy motors, the Ford GEM or solid rocket motors that are on the Delta II today that are there. The range, our partners at the United States Air Force, they play an important part in tracking the vehicle and providing personnel safety around the area for the launch. That's a huge thing that needs to be accomplished to make mission success. And of course our ULA and NASA teams, both the engineering and management teams are present today. Both teams work very close together to make sure all the systems on the vehicle are operational, configured, working properly. They understand what's been put together on the Delta II, getting ready, everything ready for this mission. That communication between all those teams is very important. So this is kind of a team sport, as we say, launching rockets. It's not just one person. We talk about NASA launch manager Tim Dunn and launch director Tom Heater from ULA, but they've got a lot of team members working with them behind the scenes to make sure we have a successful liftoff this morning.
Sure, yeah, and we're hearing a lot of chatter right now. On your screen there, you can see the Delta II there. What appears to be smoke is actually just some of the cryogenics, and the cold temperature differential there causes, ultimately it's steam, right, Mick, that we're seeing?
Yeah, it's a cold temperature difference there as we talked about cryogenic loading, the first stage. That's a very cold liquid oxygen going into there, and the vent valve, as that liquid oxygen boils off, the vent valve opens up and releases some of that pressure in the tank. So that's what we see blowing around there, and of course also the thermal differences from the outside air on the tank with the ice buildup. So that's
steam,
pretty
probably
normal.
the wrong word to use to describe that.
Not steam, just kind of thermal changes.
There you go.
Kind of like when you're outside cold and you see your breath. That's kind of what you're seeing here with the liquid oxygen temperature coming off the vehicle.
Sure, and you can see the L time and the T time. It looks like they're working on resetting those clocks now. We're running at about L minus 22 minutes and counting. And so, again, like we mentioned, that T time is a built-in hold right now, and so that will remain at T minus 4 minutes and holding, again, until that L time gets down to 4 minutes, and then we'll continue on. So I think that that aside, we're continuing on with kind of the schedule as usual. So, Mick, what can cause delays? Because obviously we're dealing with some temperatures in the tanks today, but on a grander scheme, there's a lot of things that can cause delays for launch. We've discussed weather already. Obviously, we have this with some temperatures. What else is there?
Yeah, as you were saying, Joshua, they've extended this hold, so we've got about 17 minutes and 20 seconds left built in this hold, and that allows the team to go off and look at these temperatures that we heard them talking about. They need to be able to make sure all components on the vehicle are within the right specifications and configured properly, and in this case, it's some second stage bottle temps that we need to watch and make sure they're in range prior to liftoff this morning. So that's one thing the team is continuing to do, and just watching those come down into range. We have had other things that cause delays, like you said, weather delays and stuff. Great for today. We don't have any POV of weather, and 7 miles or plus visibility. I'm very happy about that.
Yeah.
So folks will be able to see this Delta II once we lift off this morning. But unique situations on both the east and the west coast from where we launch rockets from. You can have we talked about the United States Air Force range operations, and they monitor also out in the ocean areas, because of course we're launching due south out of Vandenberg, and so we want to make sure personnel safety there. So we have a box that we kind of call the box that we have to lift off and fly into, and we want to make sure that nobody's in that box. So the United States Air Force monitors that to make sure we don't have boats. You wouldn't think about it, but sometimes boats get in the box and cause a delay, and we have to work around those things. But one unique thing out here at Vandenberg Air Force Station was Vandenberg Air Force Base was built around the railroad tracks. And so we actually have Amtrak who runs through the base, and actually pretty close to Slick 2 there where the Delta II is. And we have had in past years a train come through, and we've had to work around our launch countdown on that. So another unique feature that could possibly delay a launch. Hopefully we don't have that today, but that is a feature here at Vandenberg.
Sure, yeah. And as we've been talking about, we have what looks like a new launch time for us. We're counting down towards that. And we want to emphasize again that there's nothing wrong with the launch vehicle.
Oh, absolutely not.
These are not issues. It's just that we're not quite ready to launch.
That's correct.
There are things that take time, and they have to kind of get in the right ranges to be ready to fly. So things are going well. There's no real concerns. It's just a matter of we've got to be perfect before we can fly.
The team's very focused. They're following their procedures. They're looking at all their stuff. They're doing their due diligence to make sure we have a good rocket before we lift off this morning. We want to make sure mission success, is number one. We talk about the Delta II rocket and how historic this is being the final, and how emotional we are about it, and how we love this rocket, this baby blue rocket. But it really comes down to the spacecraft. That's what we're here for, is to make sure that ICESat-2 gets on orbit and does the science that it's been built for.
Yeah, and this kind of is an interesting time to talk about the launch window today. Our NASA launch manager, Tim Dunn, earlier in the week characterized this launch window as requiring some mental gymnastics. I loved that term. I think it's really fun. There's some unique situations where the spacecraft usually sets the requirement for a launch window based on where they're trying to go and what they're trying to do. And part of the requirement was they wanted their first day to be mostly in sunlight.
That's correct.
So for the spacecraft side, they said we have a 2-hour and 34-minute window where if you launch any time in there, we're in good shape.
Right.
And the rocket itself has a very different kind of launch window based on its capacities.
Yeah, absolutely. The history of Delta II, you heard Dr. Zurbuchen talk about. We've launched a lot of science payloads, Mars landers, GPS missions, commercial missions. Typically, those have been on an instantaneous window when we have to hit a 1 to 2 second window, something under 15 minutes, right? With the ICESat-2 mission, as you mentioned, the spacecraft identified a 2-hour and 34-minute window. So the team had to go back and look at the rocket and how we fuel it with the RP-1 and liquid oxygen. And due to LOX on board time, or liquid oxygen on board time in the tank, there's a certain requirement we have to meet to keep the temperatures of the rocket and the structure within their requirements. So once we started LOX loading, the team ran some quick calculations along with the ambient air temperatures outside, the temperature of the RP-1 fuel, and came up with a 63-minute window this evening. And so that 63-minute window is what we have available inside the 2-hour 34-minute spacecraft window. And what the team can do, and we've heard this just recently, is we can move that window around inside that 234. And so that's what NASA Launch Manager Tim Dunn and Launch Director Tom Heater have done, is they've reset that window to 1302 Zulu for our new T0 time.
Yeah, so we had the spacecraft requirements, we had the rocket ability and requirements, and then there's other things too that factor in. Like there was an issue deep into our launch window today with some collision avoidance, or you'll hear the term COLAs. We're just making sure that on launch that there's nothing that we have a potential to impact the spacecraft during ascent. And so that actually, I think that cut off a few minutes on the back end.
It did. We heard that early on in the count that we had a slightly longer window than the 63 minutes that we're identifying. I think there were 8 COLA cutouts, what we refer to as cutouts, or opportunities that we couldn't launch. They were on the back side of that window. So the team, the launch management team, decided to narrow that window to 63 minutes based on those COLA cutouts. And those are mainly safety callouts, range safety cutouts, so that we, as you said, don't hit something in space or something that's out there once we launch.
Sure. So yeah, I want to update you all. You're seeing on screen the final Delta II mission launching ICESat-2. We are targeting, I believe we're targeting a 6:02 a.m. Pacific time liftoff. So we are at L minus 15 minutes, 15 seconds and counting. Again, that T time is part of the countdown procedure, so we're still in a planned built-in hold of T minus 4 minutes and holding. We'll be progressing here soon. So we are expecting now, when we get to L minus 13 again, this time around, we're going to hear from our NASA launch manager, Tim Dunn, as he pulls his team. But can you tell us about the area? So Vandenberg Air Force Base, and in particular Space Launch Complex 2, Slick 2, in spending time with some of the folks who have been around a long time with the Delta II in particular, like there's a lot of fond memories about the location, about the rocket itself. So tell me more about the history here.
Well, as we were talking, Delta II, this final launch is very emotional for the teams. It is the final one, as we heard, Delta 381, the number of the rocket for that. But Slick 2 has been a big part of that history. Space Launch Complex 2 has a long and successful history with Delta II, and Delta launches starting back in October of 1966 with the Delta 41, the TOS-A mission. Since 1966, we've launched 83 Delta launches from Space Launch Complex 2. The last of those, or the last 44 of those, were Delta II configurations of either the 6000 or 7000 series that we talked about, that 7420 or JPSS-1, which we launched a year ago in November, was a 7920. Same vehicle, just 9 solids versus the 4 that we have tonight for ICESat-2. So over that long period, Space Launch Complex 2 has been a standing monument out here at the base, and folks really appreciate and love this rocket and this place. We have a lot of folks out here this week who've worked on this vehicle dating back to 1966, 65 actually. The teams that we've been visiting with, we heard about that, and everybody's just excited to see this final Delta II go off.
Yeah, so I think we're going to make sure we listen in and catch this poll coming in from, again, this will be Tim Dunn's voice. He's the NASA launch manager for today's mission.
Stations, this is the NLM on the NLM net. I would now like to conduct the final launch readiness poll for the ICESat-2 mission. We've got great weather. Range is clear. Spacecraft is doing superbly. Upper level winds have done really well recently. We're green till 1335 Zulu. Great news there. We've coordinated a new T0 of 1302 Z with the range, and that has been approved. And we have evaluated the second stage bottles, both helium and nitrogen. Nitrogen is back in temp, and we're waiting for helium to come back in very shortly. So we are in good shape right now to proceed toward count. So with that, I'd like to conduct our launch readiness poll, beginning with NASA CE.
NASA CE, go.
SMA.
SMA's go.
SMD.
SMD is go. Godspeed, ICESat-2.
NASA MEM.
NASA MEM is go.
LSP.
LSP is go.
NLM copies. The NASA team is go for the ICESat-2 mission on Delta II.
Awesome. So there you go. Tim Dunn concluding his poll. Not terribly long, but again, making sure that we got to make sure that we get everybody on the same page. We're all ready to fly.
Making sure that team, like we talked that team, right? Making sure the whole team is together and ready to go. And Tim is our representative to Scott Barney, the launch conductor at ULA, to give the final goal for the NASA management team and the spacecraft team. And I can just tell you, sitting here, it's exciting to hear all those goes, and everybody's ready to go. And that just means we're ready to start progressing into the terminal count. What we refer to as terminal count is the last 4 minutes of launch this morning. So with that, I just had chills hearing that from the team giving their go and being focused and ready.
Yeah, and it's great to hear Tim kind of run down the list there, making sure that weather's in good shape, the spacecraft's in good shape, the vehicle's in good shape. They're still monitoring those temperatures. Got to make sure they hit those numbers precisely, because this is rocket science.
Absolutely.
And it's got to be right.
Yeah, that's right.
And they're doing a great job working hard to make sure that we get there. So some things are going to happen here in the last few minutes. We have the final poll from
Launch conductor Scott Barney.
Thank you, of United Launch Alliance. He'll be polling his team at L-7 minutes, and that will be really the final step before we're able to come out of this built-in hold, this built-in planned hold, and we also will hear a verification that the spacecraft is on internal power. That's another big part of transitioning the effort to be ready to leave this hold and then get to lift off.
Yeah, as part of that hold, what you'll hear is Scott Barney talking to the engineering team, and basically everybody will be certifying and making sure that their systems are all ready to support liftoff this morning. And then he'll poll the launch management team also. NASA's launch manager Tim Dunn, launch director Tom Heater, who will give the final proceed to launch, and that will be good to hear us get through that and pick up the count at T-4.
Sure, yeah, and you are watching live launch coverage of the final Delta II mission to launch ICESat-2 into space here early this morning here on the Pacific coast. We are right now at about L-9 minutes, 30 seconds and counting, still at T-4 minutes and holding. Again, that's all part of the plan. We're just proceeding through the countdown. This is a very choreographed process where the steps are laid out and people have roles and responsibilities, assignments. Make sure your system's in good shape and make sure that you're ensuring that everything comes together to get us off the ground safely.
That's correct, Joshua. Team is looking at everything in serial and parallel where they can, and working through their systems and evaluating it. As we got into this slight push into this hold, the team looked at those temperatures on the tanks, bottles on the second stage, and determined they needed a little bit more time. We're hearing that those are coming in and starting to meet those requirements. So things are looking really good for us to come out of this hold in about 4 minutes and proceed towards a count at 6:02 a.m.
Yeah, you're getting a chance to see on screen a variety of our control rooms around the base here where people are monitoring systems. So everybody that you see there is a part of the process. They get to claim a piece of success today, which has got to be a great feeling. Mick, you've had that experience before. What are they going through in these last few minutes? What are they experiencing? Is it stress? Is it...
I think the team is focused. I like to use that term because we are down in that terminal count area getting ready to pick it up. We are very focused looking at everything, but we're also excited. Launch is an exciting moment, an exciting time. We work many years to get to this point. With ICESat-2, we started work with the spacecraft customer roughly 7 years ago to get to this point. So launch countdown is an exciting time for everybody that's involved, but it takes many years and many team members to get there.
Yeah, you'll have to excuse me. My train of thought got cut off. I heard Tim Dunn chime in, and he was actually declaring that we have those temperatures now back in the range when we need them to be there. So that's a great sign. That's great news. That means that, as predicted, we're now at a point where we think we're ready to fly. That final poll will be coming up here in about the next 30 seconds or so.
Yeah, I think the team is ready, and we'll hear launch conductor Scott Barney talking to his engineering team and the NASA launch management team. And coming out of that hold, we hope to get a proceed to launch from ULA's launch director, Tom Heater. So, we'll step out and let Scott Barney take over the poll here in just a few seconds.
L-7 minutes.
Status check to proceed with terminal count. Report go, no go. Talker.
Go.
FSC.
Go.
Prop 1.
Go.
Prop 2.
Go.
PEA.
Go.
PEA,
Go.
VP,
Go.
SCM,
Go.
SYS,
Go.
FAC,
Go.
ATC3,
Go.
Timer,
Go.
HYE,
Go.
FMA,
Go.
SSC,
Go.
SSP,
Go.
TM1,
Go.
TM2,
Go.
VE,
Go.
ATC2,
Go.
VSE,
Go.
OSM,
Go.
FACA,
Go.
GE,
Go.
RC,
Clear to proceed.
NASA TM,
Go.
USO,
Go.
AC,
Go.
Launch Director,
LC, you have permission to launch.
proceeding with the count. Note to personnel, switch to channel 15 after liftoff is confirmed for pad securing.
As an observer, like, it just gets your heart racing, it gets you a little bit excited.
Yes.
All good sounds.
All good sounds, and especially that last one from Tom Heater, launch director there, giving the concurrence to proceed to launch. It's, again, coming out of that hold, exciting to hear the team has everything in configuration and ready to go, and looking forward to this. We're about 1 minute and 45 seconds before we pick up the count.
We actually should get a word from our spacecraft team here in just a second, declaring that they're also fully ready to proceed.
L minus 5 hours, 30 minutes.
NSC reports spacecraft is configured for launch.
Roger. LC, spacecraft is configured for launch.
Roger.
That's another major milestone for the team, is spacecraft has been verified that they're configured for launch, meaning they're on internal power. They've switched from ground power at the pad to their internal batteries, which means they are now ready to proceed and get onto orbit. That's a huge milestone. So again, excitement here that we've gone through the polls and heard the team's ready, the spacecraft team's ready, the team's coming together, and we're looking forward to getting into the count here in just under 1 minute.
Yeah, so again, we'll be coming out of this the T-minus 4 minute
hold,
built-in planned hold. As part of a normal countdown, a choreographed countdown, it's only 10 minutes long. Today we went a little bit long. That's part of the plan. That's okay. That's what it's there for. And so we'll be coming out of that shortly. A pretty active last few minutes. You'll get a chance to hear some of the verifications of various systems being ready, making sure that everything is, it's really just a confirmation of everything being ready.
The team's finalizing their configurations. Things are going to move pretty quickly here as soon as we come out of the hold. And as I said, they're just finalizing, making sure they're all ready to go. They've given their goes, and this is just the final configurations to put the Delta II rocket into its final area for liftoff.
Yeah, absolutely. And we're going to actually see that now here in about 4, 3, 2, 1. That should be L minus 4 minutes and counting. L minus 4 minutes and counting. T minus 4 minutes and counting. Again, both those clocks are aligned now, headed to that liftoff time of 6:02 Pacific time.
Active. First stage internal.
So we hear the teams configuring.
Absolutely. Yeah, again, you're hearing those verifications coming in. So Mick, there's a big milestone that you have it's dear to your heart that comes up here in these last few minutes. Can you tell us about that?
Yeah, we're hoping to hear over the net here green board, which is a throwback to our Apollo and Mercury days, where the team looks at all their configurations and everything goes green, and the launch conductor's console, all the lights turn green, and we hear the call out for green board, which is a major milestone to say we are configured, everything's ready, let's get off and fly.
Awesome. So the other thing that's going to happen here is that when we get to after launch, you're going to hear Patrick Moore's voice. He is the United Launch Alliance launch commentator, and he'll be walking you through the first 11 or so minutes of flight. It's a very active 11 minutes.
So we just got confirmation from Tim Dunn, our NASA launch manager. He reported to Tom Heater, launch director, that NASA is go for launch, and all vehicle configurations are finishing up and getting ready to support this 6:02 liftoff.
Yeah, absolutely. So in these first 11 minutes, you'll hear Patrick Moore talking about, we have the booster jettison, we have the first stage completion, and that jettisons. We have the second stage ignition, as we saw in the profile video.
Right.
There's a total of 4 burns of the second stage this morning, and then we'll have the payload fairing separate, and then the second stage will shut down for the first time, and that's all done in about 11 minutes, which sounds like a lot of time and no time at all.
It moves pretty quickly. Once the vehicle lifts off the pad and gets on its way through ascent. You know, the first stage does its job, and the GEMs, the graphite epoxy motors, and they separate and come off. The RS-27 throttles down, and then the stage 1 separates from the whole stack. We then have payload fairing jettison, and then second stage engine start, or S1. And that'll fire, getting ICESat-2 into its initial orbit, and SECO-1, or second stage engine cutoff, for our coast phase over Madagascar, and getting ready to pick up telemetry there, and then getting ready for that second burn, for that basically a 6-second burn, just to get ICESat-2 where it needs to be going into that polar, almost nearly circular orbit at roughly 92 degrees inclination over the poles. So.
Yeah, we're at T-minus 1 minute and counting. We're going to let you just enjoy this. Again, you're watching live coverage of the final launch of the Delta II, lifting ICESat-2 into space this morning.
Water flow. 45.
LC, launch enabled to flight.
Flight.
ATC-3, main power disable on.
On.
35.
Hydraulics a go.
30.
Status check.
Go Delta 2.
Go ICESat-2.
20. 15.
Topping go.
14.
Green board.
13.
There's
12,
that green board call.
11,
That is great.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of the final Delta II, launching nearly 3 decades of science research and exploration missions, lifting ICESat-2 on a quest to explore the polar ice sheets of our constantly changing home planet.
Now 27 seconds into flight. 30 seconds in, Mach 1, Delta 2 is now supersonic. Continuing to see good chamber pressure on the RS-27, both veneer engines as well. Seeing consistent fuel and oxidizer injector pressures as well. And at T plus 46 seconds, max Q, maximum dynamic pressure. And at 57 seconds in, we have web burnout on the solid rocket motors, seeing good responses. And we have burnout on all 4 motors. And Delta will hold on to those motors for an additional 20 seconds prior to jettison. Now 1 minute 20 seconds in, standing by for motor jettison. And we have good indication of jettison of all 4 solid rocket motors. Now 1 minute 30 seconds into flight. Continuing to see good chamber pressure on the RS-27, good chamber pressures on both veneer engines as well. Seeing stable pressures on the fuel and oxidizer injector pressures. Vehicle body rates looking stable. Now 1 minute 55 seconds into flight. And 2 minutes 10 seconds in. And the booster bi-level charge is fired to maintain necessary ullage pressure in the booster. LOX tank ullage pressure response looks good. 2 minutes 25 seconds in. The booster is now beginning powered flight guidance. Body rate response looks good. And just under 2 minutes now remaining until MECO. And at 2 minutes 45 seconds into flight, continuing to see good performance on the RS-27 main engine and good chamber pressures on both veneer engines as well. Vehicle body rates remain very stable. Now passing 3 minutes into flight. Continuing to see good ullage pressures on the fuel and oxidizer tanks. Good fuel and oxidizer inlet pressures as well. And now 1 minute remaining until MECO. Three minutes, 30 seconds into flight. RS-27 continuing to perform well. Stable chamber pressure and fuel and oxidizer injector pressures, and seeing good stable pressures on both Veneer engines. Now passing 4 minutes into flight. Approximately 20 seconds remaining until engine cutoff. And booster has stopped active guidance in preparation for MECO. Standing by for engine cutoff. And we have cutoff of the RS-27. Veneer engines continuing to burn as expected. Standing by for Veneer engine cutoff. And we have good Veneer engine cutoff. And now 4 minutes, 45 seconds into flight. We've seen good separation of stage 1 and 2 and good ignition on the second stage. 4 minutes, 55 seconds into flight. Chamber pressure on the AJ-10 looks good. Body rates looking good. And we have good indication of fairing jettison. And this first burn of today's mission will last approximately 6 minutes, 15 seconds. And at 5 minutes, 30 seconds into flight, second stage engine continuing to perform well. Chamber pressure looks good. Seeing good stable hydraulic system pressure. Fuel and oxidizer feed line pressure is also looking very good. And vehicle body rates looking very stable. And 5 minutes remaining in the burn. Now passing 6 minutes, 30 seconds into flight. Continuing this first burn of the second stage. Engine performance continues to look good, seeing stable feed line pressures on both fuel and oxidizer systems and good chamber pressure. Now passing 7 minutes into flight. And now passing 7 minutes, 35 seconds into flight, seeing minor telemetry dropout, but telemetry has resumed and continue to see good performance on the AJ-10 engine, good feed line pressures on fuel and oxidizer systems, good hydraulic system pressure. Battery currents and voltages all remaining very stable throughout this first burn, and body rates on the second stage remaining very stable as well. Now passing 8 minutes into flight. And at 8 minutes 54 seconds into flight, now approximately 2 minutes remaining in the first burn of the second stage. Continuing to see very good performance on the second stage engine. Very stable fuel and oxidizer feed line pressures, hydraulic system pressure. Helium bottle pressure decay profile appears to be within family. Now 9 minutes 30 seconds into flight. Approximately 1 minute remaining until SECO 1. Now passing 10 minutes 20 seconds into flight. Seeing a slight decay in the thrust chamber pressure and fuel and oxidizer feed line pressures as to be expected for the later portion of the first burn. And standing by for engine cutoff in approximately 10 seconds. Now passing 11 minutes into flight, and we have SECO. Second stage engine cutoff. Body rates damping out well after the transients from the shutdown event.
So there you heard the United Launch Alliance launch commentator, Patrick Moore, taking you through the first 11 minutes. As you said, Mick, a lot of work, still a lot to go.
Absolutely, Joshua. You know, the team has done a fantabulous job to get here today. I can't even speak. It's I'm just
That's how exciting it is.
Yeah, I'm emotional here and exciting, but there is still a lot to go to be done to get us to spacecraft separation. As we just heard, we had SECO 1, second stage engine cutoff number 1. We're entering a long coast now, and then we'll get ready for second stage start for about 6 seconds to put ICESat on its final trajectory.
Yeah, in the meantime, we're going to send it back over to Stephanie to unpack more of the science and the research that we're doing as part of the ICESat-2 mission. Stephanie, back to you.
Thank you both. ICESat-2 is the next step in NASA's plan to study the cryosphere. Chris Gersh recently spoke with Deputy Project Scientist Tom Newman to discuss how ICESat-2 will measure the height of a changing Earth, one laser pulse at a time.
So Tom, NASA's been studying the cryosphere for a long time, and ICESat is really sort of the main mission in studying the cryosphere. Tell me a little bit about ICESat.
The first ICESat launched in 2003, and it was on orbit until 2009. The main purpose of ICESat was to measure changes in the ice sheets. Are they getting larger? Are they getting smaller? How are they changing? And the way it did that was with a laser altimeter. It sent out small pulses of laser light that bounced off the surface of the Earth and came back up to the spacecraft. By timing how long that light takes to do that round trip from the spacecraft to Earth and back again, we can figure out how far away or how near the surface of the Earth is. And by measuring the height of the ice sheet at the same place through time, you can measure whether it's growing and getting closer to the spacecraft or is it getting smaller. And what we found with the first ICESat was that Greenland is changing quite a lot, particularly in the edges of the glacier, that it's losing a lot of mass there where the ice sheet's getting smaller, and that water's being lost to sea, to the ocean, and causing sea level rise.
Now, we look at ICESat, it's done a great job, the mission's over, and now we have ICESat-2.
Mm-hmm.
Now, what happened between ICESat and ICESat-2? I understand there was a bridge. You had to keep on taking measurements between the ICESat and ICESat-2?
That's right. After the first ICESat mission ended in 2009, we knew we had to keep monitoring how the cryosphere was changing for ice sheets and for sea ice. And ICESat-2 is on the horizon, but was quite a ways away at that point. So what NASA decided to do was to use an aircraft mission, which they called Operation Icebridge, to continue to monitor those places that were changing rapidly. They use the P-3 aircraft as well as the DC-8. They do about a month-long campaign or 2-month-long campaign each spring in the Arctic and a similar length campaign to monitor places in Antarctica. With an airplane you can fly many instruments. They use a laser altimeter similar to what we use in space, as well as radars and cameras to measure those places in the cryosphere that are changing rapidly.
Any ground instruments that you use to measure the elevations?
You know, places like Greenland and Antarctica are huge. You can't really credibly cover much of that on the ground. They're simply too big. But a natural question is, how do you know that the measurements from the aircraft or from the spacecraft are correct? So what we've done is go to Antarctica, near the South Pole, where all of the ground tracks from ICESat-2 converge. ICESat-2 will be on orbit. It goes up to 88 degrees north and 88 degrees south around the Earth. So we went to 88 degrees south and we took some high precision GPS instrumentation to make a detailed survey of about 300 kilometers of the ice sheet. Now that survey is going to be one of our main reference data sets. So when ICESat-2 passes overhead and gives us some data from that area, we can compare the two and see how we're doing. Similarly, IceBridge, the aircraft campaign, flies over that same stretch of Antarctica so we can compare the ground-based to the airborne to the spacecraft.
Now I understand ICESat-2 is a much better satellite and a much better instrument on board. Tell me the difference between ICESat-2 and then the original ICESat mission.
You know, with the original ICESat, we had never done that before, have a laser in space to measure changes in ice sheets, and we learned a ton. We learned that the main action is around the edges of the ice sheets, but as importantly, we also learned that we could monitor sea ice with that. And by measuring the height of sea ice and comparing it with the height of the ocean that you can see in these cracks in the sea ice, you can figure out how thick that sea ice is, how much is sticking up out of the ocean. And we didn't even know we could do that with the first ICESat before it launched. So for ICESat-2, we used those lessons, and ICESat-2 will do a much better job of measuring changing glaciers around the edges where it's rough and it's steep, as well as measuring sea ice freeboard as that way to get at the thickness of the sea ice.
In addition to the cryosphere, I understand ICESat-2 is going to be taking elevations of a number of areas around the globe. What are some other things ICESat-2 can do?
So from the vantage point of space, you really see the whole planet. Although ICESat-2 is really designed to measure changes in the cryosphere, the ice sheets and sea ice, from the vantage point of space, you see forests. We'll measure the height of oceans, height of deserts, all over the whole planet. We have data products that cover each of those different types of surfaces. We have vegetation data products, ocean height, ice sheet height, sea ice, etc. The cryosphere is our primary objective, so the other targets are secondary, but we think they're going to be really useful for those communities.
So is it fair to say that with ICESat and IceBridge and ICESat-2, will you be able to predict down the road, I mean, just how much the poles and how much ice is melting and how much of the ocean levels are increasing over time?
Absolutely. So with ICESat-1 and now with ICESat-2, we'll be able to measure those changes in ice sheets and measure how much mass is being gained or lost in different places and how that's affecting sea level. But you bring up a good point that our data will allow ice sheet modelers to make better predictions of the future. And the way they do that is by comparing their model prediction for right now with our data. So if a model is predicting that a glacier is changing this fast or that fast, they can compare their prediction with our data to see how the model is doing. And by calibrating their models with data, it gives us more confidence in their predictions going forward when they're predicting out 100 years or 200 years. If you're getting the modern changes right, it gives you confidence looking ahead.
We are about 17 minutes into the flight of the Delta II rocket carrying ICESat-2 into orbit. Our Tori McClendon had the opportunity to speak with NASA ICESat-2 program scientist Tom Wagner to understand why we study the polar regions of our home planet.
Thanks, Stephanie. So Tom, what exactly is ICESat-2?
ICESat-2 is a laser altimeter in space orbiting the entire Earth, but it's optimized to study the Earth's polar regions.
So why is it so important for us to study the Earth's polar regions?
I know they can seem so far away, but the fact is the change that it's occurring there affects the entire planet. Loss of things like the sea ice that covers the Arctic Ocean affects our weather, and loss of ice that covers Greenland and Antarctica raises sea level.
So what exactly are we looking to gain from this mission?
One of the things we're trying to understand are the specific connections, the climate drivers of the change in the polar regions, so we can do a better job with forecasts. And ICESat-2 has been optimized specifically to capture those changes with things like its 6 beams and its orbit.
So what exactly is the difference between ICESat and ICESat-2? I think you touched on it a little bit.
So ICESat was a laser altimeter that was in orbit from 2003 to 2009. It had a single laser beam. And what was important about it was it showed us that the ice sheets were definitively losing mass and the sea ice was thinning. ICESat-2 has got 6 beams, so it's going to give us a lot more data. And on top of that, the lasers fired a much higher repetition rate, so we're going to get a lot more data in each of those beams. When we put all that together, we're hoping to much more strongly tie the changes that are occurring in the polar regions with the climate drivers.
So what about you personally? You've been working on this mission for about 10 years now, is that right?
I have, and some of my colleagues have been working on it for even longer.
So how excited are you to be here now on launch day?
So everybody is ecstatic to be here. A lot of people on the team even brought their families along. But what we're also excited about is that since we've been working on it so long, we're starting to realize that there's going to be a lot of other uses for the data beyond. Plan. So stay tuned for some exciting science.
We're all looking forward to it. Thank you so much for joining us.
Thanks for having me.
Back to you, Stephanie.
ICESat-2 was launched into space by the last Delta II built by United Launch Alliance. Launch commentator Mick Waltman from NASA's Launch Services Program had the opportunity to visit the ULA plant factory in Decatur, Alabama, to speak with 31-year veteran Dana Vandersall about the legacy of the Delta II.
I'm so excited to be here at the United Launch Alliance's rocket factory and the chance to walk down this facility and see where the historic Delta II has been produced. Dana, that has to be exciting for you also, this final Delta II coming up. Can you tell me a little bit about yourself and how you got started in this business?
I got started at the very beginning, a little prior to Delta II in Pueblo, Colorado. Started in Pueblo, Colorado. We started with the last of the 6 Delta Is. It was coming back from where President Reagan had decided that we needed to bring back Atlas and Delta again from the shuttle explosion. And then we did the last 6 Delta Is. As we were doing that, we were working on this new Delta II. And it took a while for the first one. I think it took us about 10 months in the factory to build the first Delta II. So it was a kind of a conglomeration of Delta I and Delta II. In Pueblo, we built about 120 Delta IIs in Pueblo. And we transitioned here in 2004, and we built another 30 or so Delta IIs here.
Yeah, you talked a little about Pueblo, Colorado, right? The early Deltas or Thor missions, which Delta had evolved from, were built in the Huntington Beach, California area, and then in Pueblo, Colorado. And then you talk a little bit about transition here to Decatur, Alabama, where the Delta IIs were made, right? Final Delta II, ICESat-2, that's out there on the pad. That's got to be really exciting, historic mission for us at NASA and for United Launch Alliance. Share a little bit about what you've done to prepare that vehicle for its final launch.
Well, first off, I'm very, very fortunate to have been able to work on every single Delta II. And to prepare that launch, we took extra care on the last 4. We weren't in full bore production, so we took extra time, and the last 4 were very special to us, and we spent adequate time, and they were special. We knew they were the last ones.
You know, McDonnell Douglas, who started the Thor Delta IIs, Boeing, and then now United Launch Alliance, unique thing they did, right? You work in the production area, but whenever there were problems at the pad, you guys got to travel down to the launch pads and do repairs on the vehicle as production engineers, right? So tell me a little bit how that was, going to the East Coast at Complex 17 and the West Coast at Space Launch Complex 2.
Oh, it was a great experience, and they did that because we were experienced with the build problems, and we put in all the parts. So the thinking was, if it's more than a simple change, we'll just get the guys out that normally do it and keep that experience base. So it was spectacular when you go out to the launch sites and get to work on a launch site. It was really special.
Awesome.
And the whole group, we were always kind of a small group, so we really weren't like a job or anything. We were like a family.
That was unique. You were sharing some stories with me earlier about how small the group was in Pueblo and transitioned here to Decatur. I mean, you stay in touch with a lot of those guys, or a lot of those guys still work here with you?
Yeah, I still, of course you make lifelong friends and you still stay in touch. And
yeah, you know, when we were walking around, what I noticed was how involved people were with Delta II production, how excited they were with the Delta II vehicle itself. There's a lot of memories with it, and you guys took a lot of pride in the work you did. You mentioned you took a little bit longer time on these last 4. You know, NASA bought these last 4 in 2012 for our 4 missions: OCO-2, the Orbiting Carbon Observatory, SMAP, the Soil Moisture Mission, and JPSS-1, our Joint Polar Satellite. And now, of course, our last one, ICESat-2, which is our ice monitor. We're excited to have Delta II launching these, and you know, it's been a workhorse for NASA over the years. And reliability, let's talk a little bit about reliability. Delta II is one of the more reliable rockets that's out there, right? You guys hold the world record for most successful launches in a row.
that's true, and we're very proud of that. And one of the things that helped us get there was science missions. To me personally, science missions were very personal, because I knew many, many times that it would take 30, 40 years for the technology to mature before you could get a good satellite up to do what you wanted to prove. We knew that when we'd meet the scientists and stuff, they'd come and look at the launch vehicle. They had all their budget, their whole career was tied up in this one launch. So we would try to make them as perfect as possible, and we would be kind of OCD going over them and checking them. I'd drive people nuts, but our team, we'd put them together, and we'd just try to make the best product we could. And in the science arena, she's done probably 50-some science missions. 8 or 9 of those have gone to Mars. I mean, when you get years ago, when you're working on a Mars mission, you're like, wow, this is special. It's very special.
You know, we talked a little bit about that world record. I had mentioned that earlier, and you know, when ICESat-2 launches, that will be the 100th successful launch of a Delta II. That's got to be exciting for the folks at United Launch Alliance and yourself as part of the production team.
Yes, it is. It's quite an accomplishment. We're happy and we're thrilled, and we're all looking forward to that 100th mission. Go Delta II.
The primary instrument on ICESat-2 is the Advanced Topographic Laser Altimeter System, known as ATLAS. Blair Allen spoke with the ICESat-2 Instrument Project Manager, Danya Douglas Bradshaw.
Danya, a lot has been made about the improvements between the ICESat mission and the ICESat-2 mission. You've been working primarily with the instrument, the ATLAS instrument. What is the ATLAS instrument, and what are the improvements that that instrument brings to this mission?
ATLAS is a laser altimeter. It's an instrument that is about the size of a smart car, weighs about 1/2 ton, and it has 2 lasers. I like to call it a sophisticated stopwatch. It can measure the changes in ice elevation down to the width of a number 2 pencil. And the lasers actually fire from, let's say, the distance from Washington, D.C. to Cleveland in 3.3 milliseconds.
Now, it's funny because that seems like it would have to be a powerful laser to reach that distance. But what I've heard is that it's a low-power laser. How is this possible?
You can describe it as a high-power laser and a low-power laser. It's relatively a high-power laser, but we spread the beam out so that when it reaches the ground, the energy density is much lower.
Is that done for safety reasons? Because I was wondering if I'm happen to be standing in the path of ICESat-2 when it's flying, would I be damaged if you were measuring my height on the Earth's surface?
No, it's safe for the public. It's been designed such that there's no risk to the public at all.
So the Atlas laser is very sophisticated. How does it actually get better or more data for the ICESat-2 mission?
Sure. One of the differences between ICESat and ICESat-2 is that ICESat-2 splits the laser into 6 beams. That allows us to cover a larger area, and it also allows us to have more discrete measurements along the ground, which gives us higher granularity and data in those measurements.
So obviously ICESat-2 not only is using this more sophisticated instrument, but it's getting a significant higher amount of data.
Yes.
So how do you process the data on the spacecraft and get it to the ground stations?
Oh, that's pretty exciting. I love talking about this because it's pretty interesting. So we have a very sophisticated, I like to call it, map on board. It's actually the digital elevation model. And our receiver algorithm team, as part of our testing, they actually identify the area of interest based on where we are over Earth. And they're able to modulate the amount of data that actually gets time tagged and dumped to the ground based on where we are and how much data is needed in order to be able to make an accurate measurement.
You're really collecting data on the differences you see from this map.
Yes. So we're collecting data not only on the differences as the observatory takes measurements, but we're also modulating the amount of data based on the surface type. So if you are taking measurement over a flat surface, a relatively flat surface, then you would need less data than if you were taking a measurement over a surface that had a lot more differences in the terrain.
Now, is that primarily because you just don't want to generate a lot of extra data that's repetitive, or is that more of a capability issue? It would put strain on the instrument to basically take a new survey every time it flies over.
It doesn't necessarily put strain on the instrument, so the instrument actually collects the data. The difference is that the instrument itself is smart enough to know what data needs to be downlinked. And the reason why that's important is because our data is stored on the spacecraft, on the observatory, and there's not infinite space. So you need to be very strategic and not only the data that you collect, but the data that you downlink, because there are resource constraints.
There's so much to be impressed about with regard to Atlas and ICESat-2, but what are you most proud of?
When I think about it, there are three things that I'm proud about with respect to Atlas. It's one of the largest and most sophisticated instruments that's been built here in-house at Goddard. It took a large team in order to build that instrument. We had about 350 people, and I can say that it's one of the best teams that I've ever worked with.
We are now about 30 minutes into the flight of Delta II carrying NASA's ICESat-2 spacecraft. Let's go back to NASA's Joshua Santora for more.
Hey, thank you, Stephanie. A great initial series of events. We've got a few more things to come. I'm now joined by Scott Messer, who is the United Launch Alliance Program Manager for NASA missions, correct?
Yes, that's correct.
Scott, congratulations to you and thanks for joining me this morning.
Thank you very much.
So tell me about the mission so far. Obviously, we're not done. Well, there's still more to come, but how have things gone so far? Has it been according to plan?
It has. Everything so far looks really well. The trajectory was good. All of the timing of events were well, and so far it's a very nominal mission. We're very excited.
Awesome. And so what's coming up now? Obviously, we say we're not done yet. What else is there left to do this morning?
Well, so we've got one more one more firing of the second stage, and then we'll have a little bit of a coast, and then we'll separate the ICESat mission. And then following that, we'll have another burn and short coast, and then we'll separate the P-pods and the CubeSat. So again, everything is looking good so far.
Awesome. And so what does this mission mean for ULA at large? Obviously, every mission is special, but in another sense, like this is getting the job done, business as usual. So what does this mean for ULA?
Yeah, so clearly with the last launch of the Delta II, this will be the end of an era, and we're certainly proud of the history and the record of the Delta II vehicle with 155 launches under its belt when we finish this one. It's had quite a record, and of course, nothing happens without the people on the Delta II program. So we're very proud of the people, and we stand on the shoulders of giants tonight. With that, ULA presses on. This is our 130th successful launch, and so a lot of good stuff to come.
Awesome. And so thinking about the Delta II retiring, it's not the only rocket in the ULA family of rockets. So what's the future look like for ULA and providing service to spacecraft customers?
Yeah, so certainly we've got a full manifest next year and the rest of this year actually with our Atlas and Delta IV rockets. And we got Vulcan coming online in 2020. That'll be a very exciting new vehicle, and a lot of good stuff, exciting stuff for ULA coming up.
Awesome. Scott, thank you so much for being here this morning. Again, we'll continue to monitor the progress of the spacecraft as we continue towards spacecraft separation. Congratulations to the ULA team, and Stephanie, we'll send it back to you.
Thank you.
Thanks, Joshua and Scott. Partnerships are very important to all NASA missions, and ICESat-2 is no exception. Joining us now is Franklin Fitzgerald to talk about the benefit of partnerships with companies like Northrop Grumman.
Thank you, Stephanie. As Stephanie said, we're talking about partnerships, and Northrop Grumman has a partnership with NASA with the ICESat-2 on several different levels. Tell us about them, Joe.
So we are responsible for the spacecraft bus. That's part of the LeoStar 3 product line that we make in Gilbert, Arizona. We also were responsible for many of the components that came together to make that bus, including the tanks from California and heat pipes from Maryland. Also the guidance and navigation and control SIRU that Northrop Grumman makes as well. We're pretty involved in that.
Now this bus called the LeoStar 3, right, is basically the infrastructure, the body of the ICESat and
science. High pointing buses. Specifically, the satellite is designed, the satellite bus, to point the instrument. So we have the wheels and the tanks and the propulsion that allow us to point the science instrument exactly where the scientists want it to go.
Speaking of tried and true, the Delta II vehicle, you've had some partnerships with ULA on that. Tell us about that.
We have actually, Northrop Grumman and its predecessors have been making the GEMS, the graphite epoxy motors, for many, many years. Actually, it turns out that the four that we just saw jettisoned after launch, that went very well. We've made, I think, about 1,000 of those strap-on boosters.
Now, partnerships right now and into the future, can you tell us a little bit about them before we get off?
Sure. We have and continue to be part of the cargo resupply mission for the International Space Station. That's probably one of our biggest efforts and has been highly successful. We also, though, are looking forward to the next version of that, the next contract for that's coming up, as well as we have and continue to make these large to medium science spacecraft. Currently, we launched Landsat 8, what was called LDCM, and now we're going to be working on, as we go forward, Landsat 9 and the JPSS mission.
Joe Whitaker, Northrop Grumman, Chief Engineer for the Space Systems Group, thanks for your time this morning.
Thank you, Franklin.
Stephanie, back to you.
Thank you, Franklin. Our Tori McClendon had the opportunity to speak with NASA's Director of Earth Flight Projects, Kathy Richardson. She was able to fill us in about why ICESat-2 is so important and how it fits in with NASA's other Earth science programs.
Thanks, Stephanie. So, Kathy, you oversee the Earth Science Projects Division at Goddard. Can you talk a little bit about your role?
Sure. So I'm the Deputy Program Manager, which means that at Goddard Space Flight Center, I'm responsible for all of the Earth Science missions that are managed out of Goddard. So we have multiple missions. We have missions that are just in formulation, as well as implementation and operations. And of course, ICESat-2 falls under our program office.
So of course, your role does not end at launch. Can you talk a little bit about what happens after the spacecraft gets into orbit?
Right, so the spacecraft will have about 60 days where it's going through its commissioning phase. Once that happens, it'll go into its operational phase, and then we have a whole other organization that makes sure that they take care of it and that it's runs safely on orbit, and then it provides all of the data that it needs to. We also have an organization that collects all of the data, processes the data, archives it, and then distributes it to multiple users across the world.
So this mission has been, what, 10 years in the making?
At least 10 years. We've been working on it for quite some time, yes. And we've had multiple people who've worked on it for 10 years, even longer, trying to make sure that the whole thing comes together well.
And you yourself had a different role in this mission earlier on, is that right?
That's right. So for about 3 years, I was the instrument project manager, which meant that I was responsible for Atlas, which is the only instrument on ICESat-2. So that was really exciting for me.
So how excited are you to finally be here?
Absolutely very excited. So not only do I get to be here because of my current role in the program office, being able to oversee ICESat-2, but it certainly is very personal for me since I spent so much time working with the team and being able to launch. Seeing it all happen today is just really exciting.
I can only imagine. Well, thank you so much for joining us.
Thank you.
With that, we'll go back to you, Stephanie. Has today's launch made you want to learn more about NASA? Well, Kennedy Space Center recently launched a new podcast series to give you behind-the-scenes look at what goes on. Today's launch director Tim Dunn and launch commentator Mick Waltman joined in on the fun.
I am the launch director for the Launch Services Program, and so sounds like a pretty cool job.
It does.
It is.
One of my favorite shows growing up was Star Trek, the
Star
original.
Trek. Awesome. The original.
Unfortunately, you will hear Tim wanted to be a certain character. I believe his name was Captain Kirk.
Captain Kirk. Who didn't want to be Captain Kirk?
That's a good question.
Well, that was me. I wanted to be Scotty.
It's all rockets all the time. Saddle up for our rocket roundup in this month's episode.
We are now 38 minutes after the successful launch of the Delta II carrying ICESat-2. Let's go back to Joshua and Mick to carry us through the on-orbit milestones.
Man, some good-looking guys in that Rocket Ranch promo.
Yeah, I think Tim and I look really good there.
Ooh. It's only because I was out of frame. I didn't want to steal anything from you.
But you know, Josh, you made that really fun. I think that's a great way to get space information out to the public and share. And I'll tell you, Tim and I had a great time doing that podcast with you, and we're looking forward to seeing that and how it gets out and enthusiastic, excitement for people.
Yeah, that's something that I think people may not know just about engineers in general, about people who work here in general. People probably have a perception, I hope they have a perception, that NASA is a great place to work. And when you get around guys like you and Tim Dunn, the energy is infectious.
I appreciate that.
You can't hide it, man.
I appreciate that.
It's something that we love, and it gets me fired up, and it gets me excited to be here.
I tell you, we talked about teamwork earlier. I appreciate you saying that. Tim and I get very excited about the rockets we work with and the team we work with. It does take a team, and we talked about that, to do everything in this business. And being part of the Launch Services Program team and the United Launch Alliance team and the teams that launch these missions for the NASA agency is just really exciting. It's a passion we all have. And I think if you visit us at Launch Services Program or anybody that's in this business, one of the things that you will see is that passion and that positive aura around them, because they love their job. I mean, we love getting up and coming to work every day to do just exactly what we did today, which was get ICESat-2 on its way and get this final Delta II lifted off. As I said, it was emotional. You and I were talking a little bit off camera, and I'm still feeling a little nervous waiting for spacecraft separation, but watching that final Delta II lift off was just amazing. This week Tim has actually been running around at all of our launch readiness reviews, talking to everybody that's here, asking them what their Delta number is. We talked a little bit about that. I think Stephanie mentioned that, the vehicles have been sequentially numbered since they started in the 60s. Right. And so Tim's been asking. So my number is Delta 294.
294. And that's the whole Delta family. It's not just Delta 2, just to make sure it's clear to our viewers.
That's correct. That's the Delta family dating back from 1960 to present. And 294 was the ICESat chipset mission, which was the beginning of the ICESat-2 mission that we talked about.
Awesome.
But on our team, we have some folks who've been working a lot longer than I have. Mr. George Lucian, who's part of the NASA engineering team, he was Delta 33 back in 1965. On the ULA team, our anomaly chief that you heard tonight working things with the team, Mr. Dave McFarland from ULA, he was Delta 132 at 1977. And, one of my mentors, George was one of my mentors, George Lucian, but another one of my mentors is still active with us today, is Darren Bedell. Darren, was Delta 178 in 1986. It was the beginning of a career that he's still with us, doing market analysis for Launch Services Program, finding new business, advisory work, and all kinds of things that keep Launch Services Program moving forward. So, especially those three gentlemen, I want to thank. You heard Scott say standing on the shoulders of giants. Those are definitely three that I admire and have built my career on. So I want to ask Josh, what is your number?
Sure. Yeah, it was interesting. The first meeting I was in this week, this has been something Tim's been talking about all week, and I really wasn't sure what the number meant at first because I'm new to the Delta family.
Yes.
So this is my first time really working launch, especially in capacity like this where I'm on console, and so I'm a 381. So Delta 2, Flight 155, launching ICESat-2 is my first Delta mission. So I'm a 381.
Well, you know what? As Tim said, the Delta family is large, even with this final mission that we just had. I want to welcome you to the Delta family.
Thank you. It's great to be here.
As a 381, and as a token of my appreciation, and hopefully you have many more launches, I think I'd like to pass on my Delta 2 pin
I appreciate that.
to you and welcome you to the Delta 2 family, my friend.
Hey, Mick, I appreciate this very much. I can't tell you how great it's been to work with you this week and getting ready for this launch. Congratulations to you. I know that you actually are a part of NASA's Launch Services Program. We'll kind of dive into what you all do in a little bit later on in the show. Stay tuned later in the show. Not only do we have, here in about 4 minutes or so, we have the second burn of the second stage to get ready for spacecraft separation. On screen there, you see an animation of the second stage and the spacecraft there, still on their way. I believe that spacecraft has now, we launched going nearly due south. We have, I believe we've already passed over Antarctica, and we're now coming up towards Africa. So pretty interesting to think about the orbital path of this.
Yeah, we're hoping that, or we should be seeing when we get up to this T plus 47 minute, starting up the second stage engine and then heading over Madagascar for separation.
Yeah, so can you talk about why we have multiple second stage burns? That was one of my, again, being new to the family, you got to ask these kinds of questions, learning about orbital mechanics and things. Why have multiple burns of the second stage? Why not just fire one single burn and get where you're going?
Yeah, so tonight's mission was a two-burn mission for the primary spacecraft ICESat-2. The first burn got us into that initial orbit of a circular/polar orbit for us, right? This 7-second burn coming up is going to be that last little burn that gives us the velocity and boost to get ICESat on its way, making some slight inclination adjustments to that 92-degree inclination.
The second stage engine will ignite to start the second burn.
We're listening now to an update that's coming in.
The second burn will last
I believe that's
only
Patrick
about
Moore's
7
voice.
seconds.
He's giving us an
Following
update. We're about
completion of the
3
burn,
minutes away from that second stage burn. So we're just trying to make sure we're staying up to speed on the updates coming through.
Yeah, so that second stage burn will provide that last little bit to get ICESat to where it's go. And then, of course, as you talked about earlier, we'll have 2 more burns. One to get into an inclination change to deploy our secondary payloads, our CubeSats. And then once those deploy, we will do a 4th burn over the Pacific Ocean, South Pacific area to bring the second stage back in for disposal so we don't leave anything out there floating. All those are concerned about space junk. We want to bring that back so it's not there.
Absolutely, yeah. So again, interesting path, flying nearly due south with some minor adjustments with these second stage burns. We're taking a path, I think Stephanie mentioned this earlier, where we're going to cross over the same piece of land with our spacecraft, ICESat-2, the exact same piece of land every 91 days, which requires a very precise orbit.
Yes, and Delta 2 will provide that. I have total faith in this vehicle and what it's done over the years, and we will put the spacecraft where they need to be able to perform that science. And I think it's just amazing that we can see every part of the Earth in that short period of time and take measurements down to the millimeter level of our ice caps. And that's just, we enjoy the rockets, but the science behind it is also exciting. And those guys that work the science missions on the spacecraft spend a lot of years of their lives putting this together and doing it, and it's just amazing to be part of that group to get these things going and this history that we're putting together for Mother Earth.
Yeah, so the orbital path today will take us over the eastern part of Africa. We deploy our spacecraft near Madagascar, and then we'll travel over the eastern part of Europe, and then we'll travel up and over Earth, and actually the end of this cycle will travel just to the west of where we are here. So again, the orbit jogs X number of miles to the west every orbit. And so
Yes.
eventually, 91 days later, it will pass over this specific spot again.
Yeah, we're basically flying north to south pole, right? And we're taking advantage of the Earth turning. And so as that does that, we stay in that polar orbit, and Earth turns, and so we get that full coverage of the Earth every 91 days. I think that's amazing. We're about 40 seconds away, I think, from second stage start, and we'll be listening to ULA's commentator Patrick Moore bring us through this as we get ready for this final burn.
Hydraulic system pressure is now coming up and standing by for ignition.
Again, you're watching an animation on your screen of the second stage in spacecraft.
And we have ignition on the second stage. Chamber pressure looks good and standing by for cutoff. And we have engine cutoff.
Awesome. So good calls there.
Hydraulic pressure now coming back down.
A startup and a cutoff. Obviously, the animation there, you see that as well. Again, just a great picture to kind of resemble what's going on up in space. Thankful to have those animations to help you get a chance to really kind of experience what's going on up there. Mick, we've talked about this orbit around Earth, but there's a lot that goes in beyond the teams that are here on the ground for launch, which are still actively working to make sure that this is a success. There's a lot of teams that are still going to be working past today to make sure that the spacecraft is successful. So tell us about what's involved nationally or globally in taking care of a spacecraft.
So we talked about those teams that are involved: Northrop Grumman, Goddard Space Flight Center. Once the ICESat gets on orbit and gets its solar arrays deployed, the teams will be taking over. There are some of them located in Maryland and some in Virginia. And they will be monitoring the health of ICESat and prepping it to get started and commissioned up to start doing its science work. So as we talked about, not only a big team to take care of getting launch off today, a team to get the spacecraft on orbit and maintain that for the next 3 years.
Yeah, and I know that we had a good laugh. We were talking about some of the telemetry we get from around the Earth. There's a few sites around the globe that we rely on to help us track our spacecraft, and we had an incident with an animal not too long ago. Can you talk about that? Tell our viewers.
Yeah, so actually one of our sites, the Heart of Beastock site that we'll be using tonight to track the vehicle, we tend to send a live video from there to make sure everything's working. And during the JPSS-1 mission, we actually had a gazelle type come up to one of our cameras and kind of give us a look and make sure everything was working there this evening. And the team ran those tests earlier this week with Heart of Beastock and saw some wildlife out there also. So that's a pretty cool part of launching rockets and being part of the team.
Yeah, and I believe you said Heart of Beastock is in the area of Madagascar. Is that correct?
Yes. Okay. So.
Sorry to put you on the spot, but I feel like that was what we talked about.
Yes.
So we just got a word.
And we're starting to see, actually here in the MDC, Joshua, behind us, some video coming through of the ICESat-2 spacecraft on the front of the rocket.
We're hoping to be able to have the spacecraft separation live for you. It depends on the signal.
Absolutely.
It's not a simple thing to transmit a video back from space when you're traveling in the order of 17,500 miles an hour. So that's not to be taken for granted. But that's coming up in about 2 minutes. I believe we're expecting to hear word and hopefully get to see that spacecraft separate.
And actually, there's some live video right now from the front of the Delta II second stage, and hopefully we can maintain that signal. That will be really, really cool to see.
Yeah, so we are expecting things to get a little rowdy behind us when we see spacecraft separation or get confirmation. There are some other control rooms where they'll be more focused, kind of making sure that we get through spacecraft health, which doesn't come until later in the countdown. So if it does get a little noisy, that's what's going on, is it's excitement.
Yeah, this is, like I said earlier tonight, this is what it's all about right here, is the spacecraft and getting them on orbit to start performing their science. So this is really nice to be able to see the ICESat-2 spacecraft on the front of the second stage as it's in space, getting ready for final separation here in about a minute and 20 seconds.
Now approaching.
Yeah, and again, just to preview some of the other parts of the countdown, or part of the launch sequence that will be coming up the flight, we'll see spacecraft separation. A little bit later, we'll have the solar arrays deploying, and we'll also have a third burn of the second stage to get us in position to deploy the CubeSats,
And
which is
1
a big
minute
part.
remaining until
And then
spacecraft
after
separation.
that point, we're hearing we're going to get spacecraft health report, and that's when we're hoping to really kind of declare victory over the entire flight today.
Yeah, absolutely. Spacecraft separation is just another milestone. The teams will still be focused, waiting to hear the initial state of the spacecraft and make sure everything's good. So I think the teams are looking like they're all standing up and getting a little excited here. I think everybody's on edge, still focused on what's going on.
Approximately 30 seconds
But
until spacecraft set.
we're getting closer and closer here to spacecraft separation, and glad to see that we still have live video.
Yeah, we're about 20 seconds out now, so we'll kind of just stand by and watch and listen.
And standing by for spacecraft sep shortly. And we have good indication of separation of the ICESat-2 spacecraft.
Awesome. That is great. That's what we want to see. That motion there you see on your screen is the spacecraft drifting away from the second stage. So that looks good. Obviously, we'll get full reports later, but definitely like a lot of people breathing another sigh of relief. There's
yes.
several of those that happened today.
It's just another milestone. We still have a little bit more to go. And like we said, verify that solar panels are out and get that state of health. As you had mentioned earlier, they want to get into that light, 24-hour light, and be ready to go. So we're waiting to see that. We see the teams at the Remote Launch Control Center, NASA's launch manager Tim Dunn and his team celebrating the separation of ICESat-2 there. That's a very historic moment for this final Delta II.
Yeah, and I'm sure a lot of spacecraft folks, Goddard folks, Northrop Grumman that are, again, another big sigh of relief. But I want to actually take a step back for a second and talk about the Delta II. So again, this was the final Delta II, 155th. But we were expecting the final Delta II was actually going to launch in 2011. When we launched the 2011, there was a Delta II mission, and we thought that was the last one. So, Mick, how are we here today with another Delta II?
Yeah, the teams went through this with our NPP mission here on the West Coast and Grail on the East Coast. We thought that was the end of Delta II. However, NASA still had some science missions out there, and United Launch Alliance kind of stepped up and said, we've still got some Delta IIs left. So we matched those up, and NASA's Launch Services Program was able to get OCO2, SMAP, JPSS-1, and ICESat-2 on the remaining 4 Delta IIs that ULA had. But what most people don't know is I think that they don't know that there's a 5th Delta II out there, or parts of a Delta II, I should say. Most of one. We couldn't launch it, but there is some information we'd like to share on that with those parts that are available, and I think United Launch Alliance's Tori Bruno has an announcement for us.
Hello Delta II fans. Just because we recently watched a Delta II lift off for the last time doesn't mean we have to say goodbye. I'm excited to announce that the final Delta II rocket will soon take its place in the lineup of historic rockets located in the Rocket Garden at NASA's Kennedy Space Center Visitors Complex in Florida. The Delta II rocket has been a venerable rocket for NASA and civilian scientists, the U.S. military, and commercial customers throughout its almost 30 years of service. This program comes to a close with the final launch of NASA's ICESat-2, but its legacy will continue, and the Visitors Complex will help us keep the story of success of this much revered rocket in the hearts and minds of the public. The maiden Delta II took flight on Valentine's Day in 1989, successfully delivering the first operational GPS satellite into space. Since that first launch, Delta II rockets have launched 154 successful missions. Its resume includes several trips to Mars, as well as the planet-hunting Kepler, the twin lunar orbiting Grail spacecraft, 48 GPS satellites, and numerous commercial imaging and communication satellites. These tremendous achievements are a tribute to the dedicated team at ULA and our supplier partners that ensure mission success each and every launch. So, The next time you are in Florida, stop by the Kennedy Space Center Visitor Complex and take a selfie with the Delta II and make sure and tag @ULA Launch.
So Mick, what people just got to hear is that the fifth, the fifth Delta II, which they weren't aware of, is going to be on display, and they probably don't know either that you and Tim Dunn were a part in helping to really champion that effort.
Well, I tell you, Tim and I are very excited about that. We've been pushing for something like that for quite a while, to be able to share Delta II heritage with the public. Put it at Kennedy Space Center next to the sister Thor that's out there in the Rocket Garden. Man, that announcement just that made my night tonight, just to hear that we were going to be able to show off this blue beauty to everybody, and they could get a chance to experience the heritage of Delta II, the legacy of reliability, the heritages of success that Tori talked about with these number of missions that it's done, and how much Delta II has really played a part in the U.S. government and people's lives with all the scientific missions, commercial missions, the GPS satellites that are out there that have changed the way we do business today with our phones, our computers, and all that kind of stuff. Delta II has been just an amazing rocket, and I'm I'm just a little emotional to hear that announcement, because I think that's just so great to have it right there where people can visit it.
Yeah, and that's a big congratulations to the entire Delta family, especially the Delta II family. I know that Rocket Garden is getting bigger and bigger, and it's becoming more and more beautiful. I think the more spacecraft and rockets we can add to the collection there, it's an inspiring place to be.
Oh, it is. It absolutely is. Just walking through the Rocket Garden and seeing all of the rockets that have come before, and how we've built on those, and how we've expanded and done great things as a humankind. To see Shuttle Atlantis on display there is just amazing, to inspire the next generation. That's what it's all about. You talked about Tim and I in your podcast and being positive and energetic, but we're really out there just trying to inspire the next generation from those that inspired us to get into this business and continue doing what we do. So I'm very happy to hear that fifth Delta II will be on display for everyone to see and touch.
Yeah, and you'll notice on screen there, you see again that animation. Now, obviously, the spacecraft is now out of the picture here, which is expected, and you see the second stage there with the P-pods on board. Now, it's tough to tell where those P-pods are based on there. They are in that animation, but they're pretty small. They are CubeSats. We'll hear from the NASA Edge team here in just a few minutes, but before we get to that, we're going to actually track with hopefully solar array deploy announcements. I don't think we're going to get to see anything there, but we're going to get an announcement about that. And then we're also looking for the third burn of the second stage, which will happen here in about 10 minutes or so.
Yeah.
So, but Mick, I wanted to talk about the NASA Launch Services Program a little bit, because this is a huge accomplishment for you all as well. That's the organization that you hail from, and you all are celebrating a giant milestone right about this time. This is your 20th anniversary of helping to successfully launch science missions and exploration missions to help us better understand our own planet, understand Mars, understand deep space. So big congratulations to you and the entire program.
I appreciate that. October is going to be our 20th anniversary since becoming a program at Kennedy Space Center, and this is a huge year for us. We've had 6 launches on 6 different vehicles, or will have 6 launches on 6 different vehicles. One left to go. We'll talk about that in a minute, but 6 launches, 6 different vehicles within 6.5, 7 months. That's a huge accomplishment for us as a program. We started the year off with GOES-S on an Atlas vehicle, the test mission on a Falcon 9. We then came back here to Vandenberg and launched InSight to Mars on a United Launch Alliance Atlas vehicle. And then we just recently launched Parker Solar Probe on a ULA Delta IV Heavy. You probably noticed a theme there that this ICESat-2 is our 5th of our 6 missions this year, and 4 of those 5 have been on United Launch Alliance vehicles. So again, getting back to the heritage of Delta II and reliability, we've been very pleased to partner with ULA on many of our scientific missions. And once we get done this evening, the team's not done. They're actually going to move forward, and we've got to go work on ICON on the East Coast, launching off of Pegasus, our last mission for this year.
Yeah, and again, going back to just the quality of the work that your program does and that your team does, you all deal with a lot of customers, and everybody presents unique opportunities and challenges, and it's great that we have a fleet of options to choose from. It helps provide I think you were talking about it provides a competitive process to enable competition, to make sure that the taxpayers get the best deal, the best agreement for their
money.
For their money, yeah.
Absolutely. A launch services program has a fleet of vehicles that we can choose from, and part of our job is to meet with our spacecraft customers and understand their requirements and what they need, and then we take those and we look at the performance of the fleet of vehicles we have, and then we try to match up the spacecraft customer with the appropriate launch vehicle to get them on orbit to start doing their sciences. We have a great team of analysis folks, a great team of integration engineers. We just have a great team in launch services program that does that, and people are very passionate about that job and making mission success occur for their spacecraft customer.
Sure. So you are watching now live on your screen there an animation of what is the remainder of the profile for the final Delta II launch, the mission of ICESat-2. The spacecraft is separated. We're waiting on confirmation. I haven't heard confirmation come in yet of solar array deploy. We're still waiting to hear that. And we also have the third burn of the second stage coming up here shortly. So we'll be keeping you up to date on what's going on with that. So can you talk a little bit about what's next for LSP? It's 20th anniversary. You guys are not resting and basking in the glory. You're working hard this year.
Yes.
So what's coming out for the future? I know that there are more big missions ahead.
Yes. So as I said, ICON is our next mission right up after ICESat-2. We'll be launching that on a Northrop Grumman Pegasus vehicle. That's a unique vehicle. It's an airdrop vehicle that launches from a modified L-1011, and we'll be doing that out of Cape Canaveral Air Force Station in Florida. But then the teams have to get, just because we finished that launch, the team still has a lot of work to do. We're working with our partners in Commercial Crew to try to get humans back on into space, since they're working with some of the same fleet of vehicles that LSP is familiar with. We have advisory missions that we're part of that we provide analysis and engineering services for. You can think of LSP as kind of a full-service engineering firm, right? But we work for NASA. We have NASA's interest at heart, and we kind of take a look and make sure that all our scientific missions and robotic missions and now working with our commercial crew partners, humans back to space and what needs to be done. So the team is always busy working on something, maintaining fleet insight on the launch vehicles that we have, working with new spacecraft customers. We talked earlier that, we started ICESat-2 7 years ago, so we've already started working with customers who we're going to launch in 2020 and 2021. So these things don't just come together this last month of launch. It takes a full team and a long process to make sure everything fits together and is working together for mission success.
Awesome. So thinking about the NASA Launch Services Program and our other teams on the ground here working today, what is this time like? Again, you've been on console before. You kind of know what the process is like. So we talked about the intent and focus prior to launch. Is that intent focus maintained all the way through this time? Is everybody still really dialed in on what's going on? What are the different teams working on?
Yeah, the engineering teams are still continuing to look at the vehicle performance and looking at how it performed versus the predictions that were done prior to launch, and just doing kind of an analysis, what we call a quick look of the vehicle to make sure everything performed well. Some of the team is still following the second stage here as we wait for this burn to come up and deployment of our CubeSats. We have team members looking at that. Some of the team is still following the spacecraft. We still haven't heard that solar array deploy or health check yet, but we're waiting to get that confirmation. And so the team's still focused and following that. As we saw earlier, they got to celebrate the spacecraft separation, but then they got right back and looking at the data and just making sure things were still going forward. You have to follow this mission throughout till we get that disposal burn for second stage. So the teams are going to stay on station and make sure this mission continues to end of mission.
Yeah, absolutely. So Mick, people might be wondering at home, you're incredibly knowledgeable. We appreciate you sharing that breadth of knowledge with us. So what's your background in, and how did you get here today?
So, I started with Launch Services Program back in 2000. I came from, my early career was launching Atlas rockets with Martin Marietta, Lockheed Martin. And I started out as an electrical avionics engineer with Launch Services program, and through my career I got the opportunity to join the Vehicle Systems Engineering branch, or Fleet Systems branch, and that was a huge opportunity for me to be able to expand my knowledge and learn the different fleets that Launch Services program has. And I think that's one of the unique things in our program is you aren't just stuck on one vehicle. We get to work with all vehicles that we have and all the contracts we have and learn different things. So over my career, I've got to work with just about every vehicle that Launch Services program has in their catalog. And, I'm glad to see Falcon 9 coming on board, and even some of our new entrants in our Venture Class series. And as we start moving forward with commercial resupply missions, and even some new folks that are out there that we're working with to see how they might be able to support NASA Launch Services program, like Blue Origin and Virgin One and some of those. So it's just great to get out. The passion is there to just learn new things. And so I think every day that I'm part of Launch Services program and have that chance to learn something new. I don't think learning something new is great, and we get that chance in LSP.
Awesome. Great. We are now about a little less than an hour and 8 minutes into our flight this morning, the final launch of the Delta II, launching ICESat-2 to explore polar ice sheets. We are monitoring the second stage still. There is one more burn and then some CubeSats to deploy. And like I said, we're going to check in with the NASA Edge team here. Once we get confirmation of that second stage burn, we're going to send it over their way to find out more about what those CubeSats are. It's really interesting, again, thinking about inspiring the next generation. You're going to hear about how there are students who are creating satellites to launch into space, which is just a wild concept.
And people hear about that in our education launching of NanoSats initiative, Alana, as we refer to it. And people just think it's college and universities.
Sure.
But we've actually had high schools build CubeSats. CubeSats are a unique way for students to learn project engineering, systems engineering, design, perform design reviews. NASA LSP helps some of these CubeSats with their initial PDRs, or preliminary design reviews, or CDR, critical design reviews, and get them through those milestones of systems engineering. And so the students get to learn that and become part of a team. And then if they get a chance to launch one of these on a rocket, it's just an exciting time for them to see their project go from paper to launching something on orbit. And the other unique thing about CubeSats is they all have some kind of initiative that they're trying to accomplish while they're up there. And tonight, our 4 CubeSats that we have on board, Dave, dampening and vibrations experiment is just a unique thing where they're testing tungsten particles as part of a mass dampener. So they're actually performing science and doing something with their CubeSat, right? ELFIN A and B, which are the electron loss and fields investigation CubeSats, they're studying constellations, looking at time domain changes. Again, doing some EMI, EMC work, right? And then SurfSat is looking at charged plasma on spacecraft materials. So they're using new materials and trying to learn different things there. So these are great opportunities for kids and students to learn and provide initiatives for NASA.
Yeah, it's one thing to get to learn engineering by being hands-on. It's a whole other thing when your learning experience results in putting a functioning spacecraft into orbit to get to do some science research that way. It's pretty sensational.
Absolutely, Joshua. It's, again, trying to inspire that next generation to do what they want to do, and maybe one day even come work for NASA at Launch Services program.
Hey, it sounds like a great way to spend a career.
Absolutely.
We are now getting word. We should be just about 30 seconds out from our third restart of our second stage. So we'll be bringing you that, and then we are going to pass it over to find out more about those CubeSats on board today. Again, really just a cool science.
Hydraulic system pressure is coming up as expected. Pressures look good. Standing by for ignition. And we have ignition. Standing by for cutoff, and we have engine cutoff.
So there we have cutoff, and as we said, in addition to ICESat-2, we had these secondary payloads in the form of CubeSats tonight. These small satellites developed through our educational launch of Nanosatellites program, which gives NASA partners and students an opportunity to design, test, and fly their own small satellites. And Blair Allen from NASA Edge is with several of the team members standing by for deployment of their CubeSats on Alana 18. Blair?
That's right, Mick, and we're just really glad to be here. We're going to try something very bold to go through all of the Alana 18 CubeSats right now with their representatives. And starting right now with Ryan, who's representing ELFIN. Tell us a little bit about ELFIN.
Yeah, so the Electron Losses in Fields Investigation is a space weather mission. So we're looking to see how the sun influences the Earth's magnetosphere. And our two instruments, the energetic particle detector and the flux gate, we'll see how quickly these storms dissipate or not, as the case may be.
Now, I understand that you were a late addition. You didn't know that you were actually going to ride on this mission. You had to do some last-minute work to get on.
That's right. Well, ELFIN A was on for the whole time, but we were able to put in ELFIN B. So that adds a whole lot of extra science for us. So we get to see how these storms change, both spatially and temporally.
And I'm sure when you get the science from this mission, how will it be made available to...
It's all going on the website, and scientists all over the world will be looking at it. Open data policy.
Awesome. Thanks so much, Ryan. We're going to ask your colleague to step in from Cal Poly. Thanks so much for being on the show. Sorry, just bear with us in our dynamic movement here. We want to cover these guys well. And so, Chris, you actually are from Cal Poly, and you worked on the Dave CubeSat. Tell us about Dave.
Yeah, so I worked on Dave. It's the damping and vibrations experiment from Cal Poly, and it has 3 beams in it that we excite and vibrate. And they all have tungsten particles in them at varying amounts, and we look at how they respond at every frequency through our sweep.
And basically that technology would then be transferred to other spacecraft builders so that their instruments could be better protected during liftoff and flight?
Yeah. We're looking at mostly the deployment part where you put out a boom from your satellite and making sure it doesn't shake your instrument apart.
Now, Cal Poly is, we've been to Cal Poly many times, and you guys have a long history of CubeSats. How long have you been working on CubeSats?
So I'm coming up on 4 years now. I'm in my grad year, but I've been working since my sophomore year at Cal Poly.
That's awesome. Now, have you worked with any of the other CubeSats that have launched so far?
Not the ones that have launched. I've got a few coming up, but ExoCube and ISX.
Now, is there like a CubeSat Maker Hall of Fame that you can get inducted into because you've worked on so many launched CubeSats?
I don't know.
We maybe should develop that. Now, one more question I got to ask about Dave, because does Dave stand for something, or is it literally, I thought it was from 2001 when I heard it, but it actually is for a person, right?
Yeah. So Dave's one of our lab staff members, and he was actually a student working on Dave a few years ago.
And so he where is he tonight? Is he able to watch the launch?
I believe he's watching from the VIP viewing section.
Oh, I see. They name a CubeSat after you, and then you get escorted to the VIP area. Okay. Yeah. All right, see how this works. Well, thanks so much, and best of luck. Now, you go get back on console, get ready for the launch, and we'll bring on Alex. Now, Alex, you're from a very important school, UCF. We visit Orlando all the time to go see Kennedy. I know the school well, but you work on SurfSat. What is SurfSat?
SurfSat stands for Surface Charging Sat. It studies plasma-induced charging on different surfaces and how that discharge can damage components.
And that's perfect because that helps protect spacecrafts from this electronic pulse. That's awesome. Now, another quick question. You've been involved with CubeSats how long? What's your history with the spacecraft?
It's been going on for a few years. I got brought on only the past few months to help bring it together and build it.
Did you imagine when you were filling out your application for college that before you were even done, you were going to be flying actual satellites?
No, getting into it, I had no idea what I'd be doing, but I love where I am.
And you got a really cool name with SurfSat. I mean, brilliant, right?
Yeah, it's an interesting name.
Yeah, love it. All right, well, I tell you what. Go ahead and get back on console. We're going to bring on Sean Daly, who's going to talk about the mechanism that they use to actually deploy these CubeSats.
Yeah.
Thanks for coming on the show,
my
Sean.
pleasure, Blair.
So listen, I see you're holding a significant piece of hardware.
Cradling,
yes.
Yes,
cradling very, very delicately.
Yeah.
Now, I understand this is how the CubeSats actually make their way into space. Explain the P-pod for us.
So P-pod, this is one of the deployers we have. This is what we've used exclusively on Delta II up until this point, and the last time that we're going to be able to utilize it. So this is nothing more than a holder container unit. Oh, we had our first.
Oh, that's great.
All right.
So that would have been one of the Elfin CubeSats perfectly launched. That's great. So
100 seconds from now, we'll have a second of Elfin B.
And P-pod launched, obviously.
Absolutely. So we're looking forward to this. Alex was just on here. They're going to be the final of those. And so up until this point, we've had 14 universities represented. We've had one partner to NASA, government partner to NASA. You saw that on JPSS-1.
Sure.
Yep. And so we're happy to do this. We've had 3 universities tied for with 3 launches each. So Michigan, Cal Poly, and Montana State, and UCLA today, with that first and hopefully second one going very shortly, will be tied for or will be there in second.
Yeah, I don't want to, be too pushy.
Right.
But this Hall of Fame idea that I just developed
Blair,
in the show,
I'm telling you,
we have to work on this because
you're going to be in there too, buddy. Yeah.
See, that was my subtle plan, but clearly you saw right.
You know, we know the truth.
Well, I'm hoping one day that I can develop a CubeSat as well. But it's not just the P-pod. It's not just the CubeSats. You've had other partners that help this whole process because, if I understand it correctly, this process models exactly what NASA scientists and other commercial partners go through when they want to launch a satellite.
Exactly.
Tell us about those partners.
So these students that get to work on this are going to be doing it and going to be moving in directly. When they move in from this development process and go into the second
there you
one.
Go. That's good. You love it, right?
Both of them. This is
awesome.
great.
That's Elfin B, sorry.
Yep, Elfin B is moving on. So one more to go.
Yep.
Final of the Delta IIs.
Yeah,
yep.
awesome.
So this is directly applicable to what they're going to utilize in their own world upcoming. And so this is the areas where we get to see the biggest pushes. We're seeing them now. Military's moving that way. Government's moving that way for diversified, smaller, allowing you to be able to do large science with a cloud of these.
Well, now that's interesting because Elfin, I believe, is flying in formation.
Yes, exactly
and
right.
Obviously these tandem satellites and these more complex CubeSats are being developed.
Yep.
Tell us a little bit about what's in store for the future for these.
Man, so it's moving on. It's not just CubeSats anymore. It's going to be CubeSats, and along with that, they're going to be moving up to ride shares. That you're going to see those. You saw that with Tropics coming up. Also, that's a larger version. It's going to get its own mission. So that's a team of satellites working together. You're going to be moving to ride shares, which are not just a kilogram, but somewhere in the nature of 300 to 500 kilograms, and a lot of science on those, and a lot more missions coming with them.
Now, would it be fair to say that despite the growth and the opportunity that you see in the CubeSat community, that you will always maintain these little
Absolutely.
the nanos, the smaller ones, because it seems like there's tons of applications.
There definitely is, and you see it in the commercial industry, you see it across the government, and there's opportunities here to be able to be a lot of science and a lot of capability in a small package. This learning opportunity is what
There
you
we
need.
go. Yeah.
That's so good. That's so awesome.
Yeah.
Thanks, Blair.
I love these opportunities.
I
It's
do.
great. Now, was that SurfSat that
That
was
was.
launched?
So you had Dave and SurfSat on that one.
I tell you what, this has been real tremendous. We want to see CubeSats continue, obviously,
Yep.
but we've got to go. You go join your team
Thanks.
and congratulate them for us. We're going to go back to Mick and Joshua because they have an update on the spacecraft. Back to you guys.
All right.
Hey, thanks, Blair. Obviously, we heard lots of good things. We're hearing good things now coming in.
We're actually hearing from spacecraft, we're hearing some toast on Countdown 1 right now.
And connect the world. Godspeed, Delta II, and thank you for your almost 30 years of unparalleled excellence.
So you can definitely hear kind of a little bittersweet there in the voice.
Absolutely.
Definitely some tears will probably be shed this morning, not for sad reasons. Well, I guess sad to see it go, but definitely like fond memories,
But
great teams.
Very proud of the Delta II and what she accomplished today, this final launch. And we were hearing, Josh, from the spacecraft team that commands were sent for solar array deploy, and those were verified. So we're just now kind of waiting to hear from them still on their positive health status once they get into the sun, and we hear that. Yeah, this was a successful Delta II mission. for the ICESat-2 mission, and I believe we just got the thumbs up from our NASA launch manager to give him a call on and hear what he's got to say.
This is NLM on the NLM net.
NLM, this is PAO. How are you doing today?
I'm doing great. How are you doing, Joshua? Oh, am I talking to Mick now? It sounds like.
We're both here. Mick couldn't
Wonderful.
keep from saying congratulations to you as well. Tim, congratulations to you and the entire team. Obviously, a huge success today. Everything we heard was great. So can you characterize the launch for us?
Wow. That's really what I can say is wow. It was a thrilling day. It really was. We got a little bit behind in some of our pad closeouts in getting the MST tower rolled and getting the pad ready. But the ULA team is absolutely amazing. We pressed ahead and got into the countdown sequence and continued to make up time as we moved forward through the countdown. And by about 20 minutes prior to our first target at T0, we had completely made up the entire almost 2.5 hours of delay time that we'd had. So just an incredible performance by the combined government and contractor team to get Delta II ready with its precious ICESat-2 spacecraft and get it launched.
Awesome. Yeah, you all made this look easy. This is rocket science. It is not easy, but the team looks like they just did a great job pulling together today. But on a personal level, Tim, we know that you love the Delta II. Obviously, you are committed to every mission and do a phenomenal job. So what's this one for you personally?
Besides being excited, what does it mean to you personally?
Well, obviously, I'm a little bit sad. I'm thrilled with mission success and that we were able to close the chapter on Delta II with a huge success of an incredibly important science payload. ICESat-2 is going to do cutting-edge scientific data gathering. The precision measurements it's going to make from space are just going to be incredible. So to be able to say that we launched this very important science mission on the final flight of the industry workhorse is just a huge accomplishment for the entire team. And so I have a lot of personal feelings about Delta II, but I'm really just a very small part of the entire team, and I'm just proud, honored, humbled to be part of this team that gets to close the chapter on this incredible rocket.
Tim, I appreciate those words. I don't want to keep you. I know you want to go celebrate with your team. Again, congratulations to you, to Launch Services Program, to Goddard, to Northrop Grumman, to United Launch Alliance, and the U.S. Air Force. A great morning and a beautiful launch.
Great. Thank you so much.
All right, so I think that's actually going to do it for us here today, Mick. It has been a pleasure to be here with you. I appreciate you joining me. We've had a blast, early morning, but worth it.
Yes,
and we'll go ahead and send it back over to Stephanie.
Yeah, I want to say thank you to you real quick before we do. It's been a pleasure here with this final Delta II, and to echo Tim's, it's a teamwork, and I appreciate the PAO team also for getting the word out on this final Delta II. So thanks for having me here this morning.
Our pleasure. Stephanie, back to you.
Thank you both so much. It was a beautiful launch, and we really appreciate all of those of you who stuck with us through the entire launch broadcast. To learn more about the Earth's icy areas and how these areas are changing seasonally, please visit www.nasa.gov/ICESat-2. I'm Stephanie Martin, and from all of us here at Vandenberg Air Force Base, thank you for joining us, and we will leave you with a replay of that beautiful launch.
15,
Stop and go.
14,
Green board.
13,
There's
12,
that green board call.
11,
that is great.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of the final Delta II, launching nearly 3 decades of science research and exploration missions, lifting ICESat-2 on a quest to explore the polar ice sheets of our constantly changing home planet.